Hello everyone, welcome to my channel. This is Vijay Gidturi, and in today's video, we are going to deploy a multi-microservice travel booking application on a Google Kubernetes engine. So basically, it's a full-stack web application where users can search for flights and hotels, create bookings, and make payments. And it's similar to what you see on MakeMyTrip and Booking.com. But the main focus of this project is not just the application itself, but it's the entire DevOps lifecycle. I have set up everything from infrastructure creation using Terraform to containerization with Docker, deployment on Google Kubernetes engine using Helm charts, CI/CD with Jenkins, monitoring with Prometheus and Grafana, and HTTPS with Let's Encrypt. So end of the day, entire application is accessible at my custom domain with SSL encryption, guys. Okay. So now let me show you this project architecture. So you can find this entire project architecture inside my GitHub repository. So here you can see this is the project architecture. So basically I built this entire application using a microservice architecture instead of monolithic approach. In a monolithic application, everything like user management, search, booking, payment, notification will be created in a single code base. If you want to update the payment module, you have to redeploy the entire application, and if notification module crashes, the whole app goes down. And if search is getting heavy traffic, you have to scale the entire application even though only search needs more resources, guys. Okay. But with microservice approach, each feature is a separate independent service with its own code and its own database and its own deployment. So I can update the payment service without touching anything else. And if the notification service crashes, users can still search and book flights. I can scale just the search service independently when traffic is high. Okay. So in this project, we have six separate services like a React frontend and five Go backend services. Each one run on its own container and communicates with other via REST APIs through the gateway, guys. Okay. So now let's walk through all the services. So first let me open the front end service. So this is the front end service. So the front end service is built with React.js and Tailwind CSS, and it serves the entire user interface like a login page, registration page, search page where users can search for flights and hotels, and the booking summary page and the payment page with an interactive credit card that flips when you enter the CVV. And my trips page shows where users can see and cancel their bookings, guys. Okay, so it's served through Nginx inside a Docker container, and all API calls from the browser goes through the GKE gateway API, guys. Okay, which routes them to the correct backend service on the URL paths. Okay, so you can find this front end service code inside the GitHub repository. So let me show you the code. You can directly open this travel booking application, and here you can see this is the front end. Okay, so if you open this front end, you can find entire front end service code, guys. Okay, so let me open this in VS Code and let me drop down this front end, and here you can see this is the entire front end service code, and this is the Docker file for the front end microservice, guys. Okay, now let's discuss about second service, which is user service. Now let me close this front end and let me open this user service and let me open this main.go. So basically this user service is written in Golang using the GIN framework. It handles users registration, login and the profile management. So when a user registers, the password is hashed using bcrypt and stores in userdb database in PostgreSQL. And on login, it returns a JWT token, which is valid for 24 hours. And all other services verify the JWT token for authentication request, guys. Okay. So now let me show you this in live. First, let me show you the PostgreSQL userdb database. Before that, let me connect to PostgreSQL shell. Let me open this shell and kubectl get ns. So we are running all the services inside this travel booking namespace. So let me run kubectl get pods hyphen n travel booking. Okay, travel booking. And here we need to search for PostgreSQL. So here you can see this is the PostgreSQL pod. So we created this PostgreSQL as a Kubernetes stateful set, guys. Okay. So now let's connect to this PostgreSQL pod. Let's come down, and here you can see run a single query, not this. And here you can see open and interact to PostgreSQL shell. Let me copy this command. So it is going to connect to this PostgreSQL pod, and it is going to connect to the PostgreSQL shell guys. Okay. So now let me come here and okay, let me copy and take command copy and let me paste it here. Okay. So now it will open this PostgreSQL shell. So here you can see it's connected successfully. So now let's list all the databases. Let me do slash and L. So here you can see for every service we have individual database like bookings DB, notifications DB, payments DB, search DB, and user DB guys. Okay. So this is the user DB. Inside this it is going to store all the user registrations guys. Okay. So now let me exit from this pod and let me open this terminal once again and let's come down. Okay, and let's come down, and here you can see if you want to see all the registers users in users DB, you can directly run this query. Let me copy this command and let me come here and let me paste it here. Okay, it is going to show you all the registers users. So here you can see right now we have only single user guys. Okay, with name test. Okay, so I created this user last 2 hours ago. So now let me log into this user from this travel booking portal. So the email ID is, let me come here. So this is the email ID, test@gmail.com, test@gmail.com, and the password is test@123 guys. Okay, so let me select here sign in. So here you can see it's connected to this user. So right now we are on test user. So if you want to sign out, you can directly select here sign out guys. Okay, so now if you select my trips, here you can see all your trips guys. Okay, so if you cancel this trip, it will go to this cancellation tab. I will show you this later guys. Okay, while explaining other microservices. So now let's try to register a user and let's try to log in through that user guys. Okay, so let me sign out from this. So if you want to create a user, first you need to create a free account. So here you need to select create a free account. So again, before creating this free account, let me run this query once again. Okay, so inside this users DB, right now we have only single user. Okay, so now I'm going to create another user. So the name is Vijay and the email address is vijay@gmail.com and password is vijay@123 guys. Okay, and confirm password vijay@123 and create free account. So now here you can see account is created and currently we are on user Vijay. Okay, so now let me come here and let me query this user DB. So now here we need to see user Vijay. So here you can see a new user has been created guys. Okay, so now if you want to create another user, you can directly sign out from this and you can directly create a new user. So here you need to select a create free account and directly provide any name and email address and password. Okay, so let me provide the password Naresh@123 and similarly Naresh@123 and create free account. Okay, so now here you can see account is created. Now it's on the Naresh user. So now if I come here and again if I query for this user DB and it will show the third user. Here you can see third user is Naresh guys. Okay, so if you want to sign out, you can directly sign out, and if you want to connect to this Vijay user, you can directly come here and you can directly provide your mail vijay@gmail.com and password vijay@123 and sign in. Okay, so now here you can see we are on user Vijay, but we haven't booked any flights and hotels yet. Okay, so let's book these flights and hotel in next few minutes. So now let's move on to next service, which is search service. Before that, let me come here and let me close this user service and let me open this search service case. Okay, and let me open this main.go. Okay, before explaining about this search service, let me drop down this user service, and this is the docker file for the user service guys. Okay, so now let me open this search service and let me open main.go. Okay, so the search service is also written in Golang and it provides flights and hotel search functionality. What's interesting here is it uses Redis caching. So when a user searches for flights from New York to Los Angeles for the very first time, it queries PostgreSQL and stores the result in Redis with a 5 minutes TTL guys. Okay, and returns the data as okay. And if the another user searches the same route within 5 minutes and it serves directly from the Redis, which is much faster, guys. Okay. And this search service comes with the preloaded with seed data with 20 flights across 10 routes and 20 hotels across 10 cities, guys. Okay. First, let me show you search service Go code. So basically, this is the search service entire Go code, and this is the Docker file for the search service, guys. Okay. So now let me show you all the flights and hotels data by connecting to the PostgreSQL shell. And let me come here. Let me open this Postgres. Let me come up and docs, and this is the file, guys. Okay, PostgreSQL database guide.md. So now let me come down. So let me come down. This is the user DB, and this is the search service. Okay. So now if you want to see all the flights, you can directly run this command, guys. Okay. Let me copy this command and let me directly paste it here. Okay. So now we are going to search all the flights inside this search DB. Now let me hit enter. And here you can see these are all the flights available across all the 10 cities. So now let me open this and let me come here. So if you want to count total flights, you can directly run this command and you can directly paste it here. Okay. So it will show you total count of the flights. So total count is 20. So I will explain all these commands later, guys. Okay. So let's come down. Similarly, if you want to see all the hotels, you can directly run this query. Let me copy this and let me paste it here. Okay. Let me remove this. Let me copy this once again and let me paste it here. So we are going to search all the hotels inside this search DB, guys. Okay. So these are all the hotels available across all the cities. So now if you want to count all the hotels, you can directly copy this query and you can directly run here. Okay. So let me cancel this. Let me copy this command once again and okay, let me paste it here. So it will show you the total count of hotels. So total hotels are available is 20, guys. Okay. So I will explain you about all these commands later, guys. Okay. So now let's try to search these hotels from the UI. Let me open this UI and here you can see you need to provide from and to destinations, guys. Okay. So from is New York to let's select Los Angeles and search flights. Okay. So here you can see it is showing all the flights, guys. Okay. So this is how this search service will work. Okay. So all the data is coming from this table, guys. Okay. So now let's come here. Now, if you want to search with some different locations, you can directly remove this New York and let me select here Chicago. And now let me remove this Los Angeles. Now let me select here Dallas and search flights. So now here you can see these are all the flights available from, let me come here, from Chicago to Dallas, guys. Okay. So these are all the flights available. So if you want to sort the price, you can directly drop down this and you can directly provide price high to low or else price low to high or else shortest. It will show all the flights, guys. Okay. With this max USD. Let me provide here high to low. Okay. From high to low, these many flights are available from Chicago to Dallas, guys. Okay. So now the fourth service is booking service. So let me open this VS Code and let me close this search service and let me open this booking service and let me open this main.go. Okay. So the booking service is also written in Golang and it is creating and managing flights and hotels bookings. Whenever a user books flights, it stores the booking in a booking DB database with a user ID, flight reference, travel data, and passenger details. And it also supports cancellation, so users can cancel bookings from My Trips page, guys. Okay. So now let's see this in live by booking some flights and hotels. Before that, let me show you this Docker file. So here you can see this is the Docker file for the booking service. So now let's try to book some flights and hotels. Before that, let me show you the Postgres database for this booking service. Let me open this PostgreSQL database guide and let me come down. So this is the bookings DB. So here you can see all bookings. So if you want to see all the bookings of this travel booking application, you can directly run this query, guys. Okay, so let me copy this and let me come here and let me clear the screen and let me paste it here. Okay, so here you can see right now we have only single booking. So we book this from test user, guys. Okay, so let me come here and let me connect to the test user. Okay, test@gmail.com and the password is test@123. Okay, so here you can see this is the booked flight, guys. Okay, so now let me cancel this and okay. So here you can see I just canceled this booking, right? So now let me run this query once again. So now it will not show this, guys. Okay, so it's not doing. Let me run this query once again. Okay, so now if you want to count total bookings, you can directly copy this query and you can directly run that query here, guys. Okay, so it will count the total number of bookings. So here you can see currently we have only single booking, guys. Okay, so now here you can see if you want to see only flight bookings, you can directly run this query. If you want to see only hotel bookings, you can directly run this query. And if you want to see only confirmed bookings, you can directly run this query. And if you want to see only cancelled bookings, you can directly run this query. Okay. So all the queries are working, guys. Okay. So now let's try to book some flights and hotels. Let me come here and let me connect to my user, which is vijay@gmail.com, and the password is vijay@123 and sign in. Okay. So now from this page, I'm going to book a flight. So let me select here New York to Chicago, and I want to travel on this month 22nd and passenger is 1. And let me select here search flights. So this search functionality is working with search service. So now I'm going to book this flight. So let me select here book now, and here you can see you need to provide all the passenger details. So let me provide first name as J and let me provide last name as Gidturi. Okay, email vijay@gmail.com, contact number 123456789. Okay, so now if I select here confirm and pay, this will be handled by payment service, guys. Okay, so let me select here confirm and pay, and here you need to provide your payment details like card number, card holder name, expiry date and CVV, guys. Okay, now these details will be handled by payment service. Okay, so let me do some sample payment 123456789 123. Okay, let me select another number. Okay, so now card holder name is Vijay and 0828 and CVV. You can provide any dummy values, guys. Okay, and if you select here pay, this will be handled by the payment service. But still I haven't explained you about payment service. Now let's discuss about this payment service, guys. Okay, so here you can see payment is completed. If you want to download this invoice, you can directly download this. Now you can see this entire bookings in my trip page. Let me select here my trips. So here you can see flight booked, which is confirmed. So departure on May 22nd. So it comes under upcoming. So if you want to cancel this, you can directly cancel this case. Okay. So now let's discuss about payment service. So this is the fifth microservice. So let me open this and let me close this booking service. And now let me directly jump on to payment service. Payment service. Okay. So this is the payment service. So now let me open this main.go for the payment service. Okay, so basically this payment service is also written in Golang, and this payment service processes payments for the bookings, and it simulates credit cards payment processing, and it accepts the card number, expiry, CVV and validates them and creates a transaction record in the payments database, guys. Okay, what's nice about this service is it exposes business metrics to Prometheus and total successful payments, failed payments, and total amount processed in dollars. So we can monitor revenue in real time on Grafana, guys. Okay. So here you can see this is the entire Go code for this payment service, and this is the Docker file for this payment service case. Okay. So now once again, let's try to do some payments by booking some flights and hotels, and let's check the database also guys parallelly. Okay. So now let me open this portal once again, and let me select here search. Okay. So now this search is handling by the search service. So now let me select Los Angeles to San Francisco. Now let me select here date as 20th of this month. Now passengers are 2. Let me increase this to 2. Now let me select here search flights. So now here I need high to low. Okay. Now I'm going to book this flight. Okay. I'm going to book this flight. Now here this is handling by the booking service guys. Okay. So let me select these details. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And let me remove this, and you can directly select here confirm and pay. So this will be handled by the payment service guys. Okay, let me select here confirm, and here you can see now you need to provide your card number, card holder name, experience CVV. This will be handled by the payment service guys. Okay, so now let me provide these dummy values. Okay, so now card name let me provide as Vijay, and expiry 26, let's provide. Okay, and 566 pay. Okay, so now here you can see this is handling by the payment service guys. Okay, so now if I select my trips, and here you can see we have two more trips added guys. Okay, so this is scheduled on 22nd of this month, and this is scheduled on 20th of this month guys. Okay, so this comes under upcoming. So now let's check this on the database. Let me open this and see all bookings. Okay, so you can directly run this query. So now we are going to see all the bookings inside this booking DB. So let me copy this query, and let me open this, and let me copy once again. Let me hit enter, and here you can see, so this was not showing. Okay, so now okay, this is showing guys. Okay, so this is cancelled, it is showing. Okay, so now here you can see two more flight bookings were added. Okay, so now similarly if you want to book hotels, you can directly open this portal and directly search and directly select your hotels guys. Okay, so you need to select this option. Now city, I'm going to select New York, and check-in time I'm going to leave as it is, or else if you want to customize, you can directly select here customize, like I'm going to select 16th, and checkout is 17th, and guest are 2 members, and search hotels. Okay, so this will be handled by the search service guys. Okay, so here you can see right now in this for New York City we have only two hotels from this travel booking application guys. Okay, so now I'm going to select this hotel book now, and this will be handled by the booking service. Let me provide Vijay. Okay, now let me remove this. Now let me select here confirm and pay. So now this will be handled by the payment service, because you need to provide all the card details. Let me provide some dummy card details, and Vijay, expiry 934, CVV 544. Okay, so here you can see when I was selecting CVV, here it is not showing the CVV guys. Okay, so here you can see this is the it will work similarly like real-time application. Okay, so let me select here pay, and this will be handled by the payment service now. Okay, so here you can see payment is confirmed. So let me select here my trips, and here you can see we booked an hotel. So now if you want to check this hotel inside this bookings DB, you can directly run this query, and okay, let me go up, and here you can see all hotels, count total hotels. Okay, let me run this query, and let me come here. Here we need to see one new hotel, guys. Okay, so here you can see hotel booking has been added successfully, guys. Okay, so this application is going to work like a real-time application, guys. Okay, so now let's come down. So if you want to check for payments DB, you can directly run this query. If you want to see all the payments, you can directly run this query. Let me copy this. Let me paste it here. Okay, okay, let me copy this properly. And here you can see these are all the payment details, guys. Okay, so now let me come here. Now if you want to count total payments, you can directly run this query, or else let me copy all these commands and let me paste it here, guys. Okay, that will be better. And here you can see these are all the total number of bookings. So total payments are 4. And here you can see what's the third one. So the third one is successful payments. So here you can see these are all the successful payments. Now the fourth one is failed payments. So here you can see we don't have even single failed payment. So the fifth one is total money collected. So let me come here. So total money collected from this travel booking application is 3,736 USD. Now let me come here. If you want to see payment method details, you can directly come here and you can see all the payment method details, guys. Okay. So here in this we have some syntax error. So I will fix this, guys. Okay, no problem. So now let me come here. So now if you want to check for notification DB, you can directly run this queries, case. Okay. So before that, let me explain you about this notification service. Let me come here to VS Code and let me close these payments and let me open this notification service, guys. Okay. Now let me open this main.go for the notification service. So basically this notification service is also written in Golang, and the notification service sends booking confirmations and updates to users, and it uses Redis as a message queue for processing notifications asynchronously, guys. Okay. So these are the 6 main services. As part of this, we also have Postgres for the database. I'm running a single PostgreSQL instance as a Kubernetes stateful set with persistent storage. But instead of one database for everything, I created 5 separate databases inside it, one for each service. And this gives us the microservice benefit of database isolation while being resource efficient by running just one PostgreSQL pod, guys. Okay. And the databases are created automatically via init script when Postgres starts for the very first time. Okay. Now let me show you this in live. Let me open this terminal and let me clear the screen. kubectl get pods or else kubectl get all hyphen n travel hyphen booking grep postgres case. Okay. So here you can see this is the PostgreSQL pod and this is the PostgreSQL service and this is the PostgreSQL stateful set, guys. Okay. So now if you want to see all the databases inside this Postgres-0 pod, you can directly open this guide and let me come up and let me connect to this PostgreSQL shell using this query. Let me paste it here. Okay. We copy it once again. So it is going to connect to our PostgreSQL shell. So it's connected successfully and /l. Okay. So here you can see these are all the databases we created for all the microservices for booking DB, notification DB, payments DB, search DB, and user DB also, guys. Okay. And apart of this PostgreSQL, we are also having Redis. So Redis is used as an in-memory cache by such service by catching such results and by the notification service as a message queue, and it significantly improves search response times for repeated queries, guys. Okay. So if you want to see that Redis, so we are running that inside this travel booking namespace. Let me exit from this Postgres. Now let me do kubectl get pods hyphen n travel hyphen booking, or else let me run this query kubectl get all hyphen and travel booking and grep redis. Okay, and here you can see this is the redis pod, it's running, and this is the redis service, redis deployment, and redis replica set, guys. Okay, so now let's discuss about Docker. Let me open VS Code and let me open any of the Docker file, guys. Okay, so let me open notification service Docker file. So basically, every service is containerized using Docker, and we are using Docker multi-stage builds for all the 5 Go backend services. And the first stage uses Golang image to compile the binary, and the second stage copies just the binary into the minimal Alpine image, guys. Okay, and this keeps the final image very small and secure. So now let me open front-end Docker file. Me drop down this and let me open this front-end Docker file. And for the front-end, the first stage builds the React app with Node.js, and the second stage copies the build files into an Nginx container, guys. Okay, so this is about Docker files. Now for local deployment, we have Docker compose file. Let me close this and let me open this Docker compose file. So basically this file starts all the 9 containers like Postgres, Redis, 5 Go backend services, front end, and an Nginx gateway with a single command. Anyone can run this entire application on their laptop without needing Kubernetes cluster using this Docker compose file, guys. Okay. So I will create a small video about Docker Compose using this repository, okay, after completing this project. So now let's discuss about our Terraform scripts. Let me open GCP-Terraform. So you can find all the Terraform scripts inside this GCP-Terraform directory. So now for infrastructure, I am using Terraform with a modular approach. Instead of manually creating resources in GCP console, we have Terraform scripts that creates everything with a single Terraform apply command, guys. Okay. So basically it's create a VPC with a subnet for network isolation, firewall rules for SSH, HTTP and HTTPS, and health check traffic, and a GKE cluster with an auto-scaling node pool that scales between 2 to 5 nodes based on load, and an artifact registry to store our Docker images, and a global static IP address for the gateway API load balancer, guys. Okay, and each resource type is a separate Terraform module like a VPC, firewall, GKE, artifact registry, and static IP. So this modular approach makes the code reusable and maintainable. And the Terraform state is stored in a Google Cloud Storage bucket, guys. Okay. So if we need to tear down everything, we can run Terraform destroy command, guys. Okay. So Terraform removes all this infrastructure, guys. Okay. So if you want to check this, let me come here and let me do ls and gcp-terraform and ls. Let me run this command terraform state list. Okay, so it is going to show you all the resources we created using Terraform. Apart of GKE, we created all the resources like artifact registry, all the 3 firewall rules, static IP, and VPC and subnet. But we haven't created GKE cluster using Terraform due to lack of quotas, guys. Okay. So here you can see you can find all the modules inside this modules directory. So this is the module for artifact registry, and this is the module for firewalls, and this is the module for GKE, and this is the module for static IP, and this is the module for networking, which is VPC, guys. Okay, but I'm not going to create GKE cluster using Terraform due to lack of resources, but I just tested this all Terraform scripts, guys. Okay, so you can create a GKE cluster using Terraform. Okay, so now let's close this and let's open Helm, and let me open these templates, and let me open this values.ml file, guys. Okay, now let's discuss about Helm chart. For Kubernetes deployment, we are using Helm chart. So here basically Helm is nothing but it's the package manager for Kubernetes. Instead of applying 40 individual ML files one by one, we run one Helm install command, and it creates everything like 7 deployment, 1 stateful set, 8 services, 6 config maps, 5 secrets, and all the configurations like image tags, replica counts, database credentials, domain name is in a centralized values.ml file, guys. Okay, when I need to upgrade anything, we need to change our values.ml file and run helm upgrade command, guys. Okay, and if something goes wrong, we can use helm rollback. It can roll back to the previous working version in seconds. Okay, so helm keeps a version history of every deployment, guys. Okay, so now let me show you this helm chart inside this terminal. meaning inside this GKE cluster. Let me close this and Helm ls-a. So it is going to show you all the Helm charts. So here you can see this is the travel booking application Helm chart. So this is the total Helm chart, guys. Okay, so using this Helm chart, we created this one, guys. Okay, so this is the Cube Prometheus stack one, and this is Jenkins and Cert Manager. Even we are running Jenkins inside this GKE cluster. Okay, next I'm going to explain you about Jenkins. First, let's focus on this travel booking Helm chart. Now let me do kubectl, or else let me show you Helm status travel booking -n travel booking. Okay, let me use some space here. So here you can see this is the entire status. Name is travel booking, last deployed on this time frame. Namespace is deployed on travel booking. Status is deployed, so the revision is 1 and pursuit is none, guys. Okay. So now let me run this command kubectl get all -n travel booking. So it is going to show you all the pods, deployment services, replica sets, and stateful sets, and horizontal pod autoscalers inside this travel booking namespace, case. Okay, so you can see this is the booking service pod, and this is the front end pod, notification service pod, payment service pod, and Postgres pod, and Redis pod, search service pod, and user service pod, guys. Okay, so these are all the services like user booking service, front end service, notification service, payment service, Postgres service, Redis service, search service, and user service. Similarly, these are all the deployments. These are all the replica sets, and this is the stateful set for our PostgreSQL database. And these are all the horizontal pod autoscalers for all the services. If you see booking service autoscaler, front end autoscaler, notification service autoscaler, payment service autoscaler, search service autoscaler, and user service autoscaler, guys. Okay. So now, still we created few more resources like gateway, kubectl get gateway -n travel -booking, and here you can see this is the gateway. So we created this gateway from Helm chart itself. Now let me show you http routes. Okay, so this is the http routes, and in this project we are going to use ingress controller as Kubernetes gateway API. So let me show you that kubectl get gateway classes, and here you can see these are all the gateway classes, guys. Okay, so in this project we are going to use Kubernetes gateway API. So now let me show you config maps for the travel booking application. Kubectl get cm-n travel booking. Now let me show you secrets. So here you can see these are all the secrets like booking service secret, notification service secret, payment service secret, Postgres secret, search service secret, and travel booking TLS secret, and user service secret, guys. Okay, so now let me show you secrets. Okay, so these are the secrets, right? Let me show you stateful set in travel booking namespace. So here you can see this is the stateful set, which is PostgreSQL. Now let me show you HPA finally. HPA, horizontal pod autoscaler for all the microservices. So here you can see this is the horizontal pod autoscaler for all the microservices, like for booking service autoscaler, front end autoscaler, notification service autoscaler, payment service autoscaler, search service autoscaler, user service autoscaler, guys. Okay, all these Kubernetes resources were created using Helm chart, guys. Okay, now let me open this Helm chart. So here you can see these are all the ML manifest. So this is the booking service config map, this is the booking service deployment, and this is the booking service HPA, this is the booking service secret, and this is the booking service case. Okay, so these are all for front end deployment, front end HPA, front end service, and this is the gateway we are going to create using this Helm chart, and these are all the HTTP routes for all the microservices. Next, this is the notification service config map, notification service deployment, notification service HPA, notification service secret, and notification service case. Okay, and these are all for payment service config map, payment service deployment, payment service HPA, payment service secret, and payment service case. Okay, and this is PostgreSQL initDB config map, and this is the Postgres secrets. So basically, we are going to store PostgreSQL username and password inside Kubernetes secrets, and this is the Postgres service, and this is the Postgres stateful set, guys. Okay, and this is the Redis deployment, and this is the Redis service, and now this is the search service config map, and this is the search service deployment, and this is the search service horizontal pod autoscaler, and this is the search service secret, and this is the search service, and this is the user service config map, and this is the user service deployment, and this is the user service horizontal pod autoscaler, and this is the user service secret, and this is the user service guys. Okay, so total we have 40 ml manifests. So we are passing all the values inside this values.ml file, guys. Okay, so these are all the values for across all the 40 Kubernetes ML manifest, guys. Okay, so this is about Helm chart. So now let's discuss about Jenkins. Now let me open this tab and let me open Jenkins. So let me refresh this entire page. Okay, so let me keep like this. So now for CI/CD, I'm running Jenkins inside GKE cluster itself. We are not going to maintain a separate virtual machine. Jenkins will be installed within the GKE cluster using Helm. And this is one of the best part of this project, guys. Okay. So when a pipeline runs, Jenkins dynamically creates an agent pod with multiple containers like Docker for building Docker images, and Go for testing all the 5 Go backend services, and Node.js for testing frontend, and Helm for packaging, and gcloud for deploying to GKE, guys. Okay. Once the pipeline finishes, these agent pods will be automatically destroyed. So there are zero idle resources when no builds are running, guys. Okay. So the pipeline has total 14 stages. So it starts by cloning the GitHub repository, and then it tests all the 5 Go backend services and the front end. Then it is going to build all the 6 microservices, and it is going to tag them with the latest Jenkins build number. And parallelly, it will push those Docker images to GCP Artifact Registry. After that, Trivy scan all the Docker images for security vulnerabilities. Then it is going to update Helm values.ml file with new image tags, and it is going to package the Helm chart. And parallelly, it is going to push that Helm chart to GCP Artifact Registry, guys. Okay. And finally, it connects to the GKE cluster and pulls the latest Helm chart from the GCP artifact registry. And it is going to run Helm upgrade command to deploy new version of our travel booking application to the GKE cluster, guys. Okay. And currently, Jenkins is also accessible via the domain with https://vijaygirituri.in/Jenkins, guys. Okay. And here you can see connection is secure. Even for this portal, this connection is secure. For Jenkins, this connection is secure, guys. Okay, and if you want to see the certificate, you can directly see the certificate, guys. Okay, so I will explain you this in next steps. Now let's build this Jenkins pipeline, and I will show you how agent pod is scheduling another pod for the Jenkins build with multiple containers. And let's see how latest Helm chart is deploying to GKE cluster, guys. Okay, so before that, let me show you this Jenkins Helm chart and all the running resources for Jenkins inside the GKE cluster. So let me open this terminal once again. Now let me clear the screen. Initially, let me run helm ls-a. So I'm going to run this Jenkins in the default namespace itself. Let's wait for some time. It is loading. Okay. So here you can see Jenkins. So we created this Jenkins in the default namespace. So now if you want to check the status of this Jenkins, you can directly run helm status Jenkins. Okay. So it is going to show you the status of Jenkins. So here you can see name is Jenkins, last deployed on Thursday, May 14th. Namespace it's deployed on default, status is deployed, and the revision is 1. Okay. So the username is Vijay, and password I just kept Vijay@123. So we installed this Jenkins using our custom values.ml file. Let me come out from this gcp-terraform directory and cd Jenkins and ls cat custom values.ml file, guys. Okay, so using this values file, we created we installed Jenkins on GKE cluster, guys. Okay, so here you can see this is the entire pod template. So it is going to use all these 7 Docker containers like JNLP, Canico, Node.js, Golang, Docker, and Helm and gcloud. Okay, So it is going to use all these pod template to build and deploy our travel booking application to GKE cluster, guys. Okay. So now let me clear the screen. Let me run kubectl get all and grep Jenkins. Okay, so it is going to show you all the resources related to Jenkins in the default namespace, guys. Okay, because we install Jenkins on the default namespace. So this is the Jenkins pod. So this is the main agent pod, and this is the Jenkins service, and this is the service which is Jenkins agent service, and this is the stateful set for the Jenkins, guys. Okay, a part of this, it will create PV and PVC. Let me hit enter. So here you can see this is the Jenkins PVC we created with the 15 GB of persistent volume client. So let me open this Jenkins. So all these jobs build data, it will store inside this PVC, guys. Okay. So that is the reason why I just created with 15 GB of PVC. But we are just creating this for sample video purpose, right? You can create with the 1 GB or 2 GB of PVC, guys. That is more than enough. Okay, because it can store up to 100 builds, guys. Okay, so now let me come here. So a part of this, we have HTTP route for Jenkins kubectl get HTTP route and grep Jenkins, and this is the Jenkins HTTP route. And a part of this, we also have health check policy for Jenkins. So this is the health check policy for Jenkins, guys. Okay. So now let's try to run this Jenkins pipeline, guys. Okay. Before that, let me do one thing. Let me do kubectl get pods hyphen watch. So let's watch this Jenkins pod continuously. So this is the main agent pod, guys. Okay. So now when we run this Jenkins pipeline, let me come here. When we run this Jenkins pipeline, this agent pod will create worker pod, and it is going to, in that worker pod, it is going to run almost 7 Docker containers like JNLP, Canico, gcloud, Helm, Node.js, Go. It is going to run all these Docker containers, and it is going to run these jobs inside those Docker containers, guys. Okay, so let's see this in live. Let me select here build now, refresh this page, and here you can see third build is started, right? Let me open this and console output. Meanwhile, let me come here. So here you can see immediately this agent pod is created one worker pod. So here you can see its container creating, now it's running. So inside this it is running almost 7 Docker containers, guys. Okay, so if you want to see all those Docker containers, you can directly describe this pod kubectl describe pod, and this is the pod name, and I'm going to show you all the containers. Okay, so in events you can see all the Docker containers. So here you can see this is the Canico, and this is the Node.js, and this is the Golang, Docker, Helm, and gcloud. Okay, so these are all the containers it will be created. Now within these containers it is going to run this it is going to build this jobs, guys. Okay, so here you can see currently it is cloned this repository. Now it is going to do the testing, guys, for all the 5 Go backend services. Right now it is entered to the user service, and it has run go mod download and go mod tidy. Okay, so after completing this, it has went to such service, and it has run this command go mod download and go mod tidy. Okay, so now it is doing the wet testing. Meanwhile, let me open this. Okay, so now here you can see for payment service also it's completed, booking service is completed. Right now it is doing testing for notification service. So here you can see all Go services passed testing. So now it is going to do testing for the front end service, guys. Okay, let me open this in a new tab, and here you can see here it is going to scan all the 5 Go backend services. Now it is going to scan our front end service, guys. Okay, let me open this. And after completing this, it is going to log into our GCP Artifact Registry. Next, it is going to build all the microservices one by one. Like it will start with user service. It will build the Docker image and it will tag the Docker image with the latest Jenkins build number, and it will push this Docker image to GCP Artifact Registry, guys. Okay. So here you can see it is building. So for the very first time, it will take some time, but for second time using KHA, it will build very fast, guys. Okay. So here you can see all the services was built successfully. Let me come here. So here you can see. First, let's check for any single microservice. Let's check for front end. So here you can see it has went to front end using this command. It has built this front end Docker image and it is tagged with 1.0.3 because the build number right now it's 3, guys. Okay. Now, similarly, after building this Docker image, it will push this Docker image to GCP Artifact Registry, guys. Okay. So let's wait for some time. I will show you that for front end. Let's come here, or else let's go to other microservice. Okay. So here you can see. Let me check the microservice name. So this microservice name is notification service. So it has went to notification service. It has built this Docker image and it is tagged with 1.0.3. And after this, it has pushed this Docker image to GCP Artifact Registry, guys. Okay, with 1.0.3 tag. And after that, it came to front end. And let me check for front end. So currently, it is building this front end Docker image, guys. Okay. So let's wait for some time. Meanwhile, okay. Meanwhile, if you want to see GCP Artifact Registry, you can directly come here and let me open GCP Artifact Registry. Artifact Registry, and let me open this tab. And here you can see this is the GCP Artifact Registry travel booking. Okay. So this repository we created using Terraform, guys. Okay. And here you can see we have all the microservices Docker images. Front end also it's built and it's pushed it just now. Okay. So here you can see all the microservices Docker images are available inside this GCP Artifact Registry. So now here you can see Trivy is going to scan this Docker image, and initially let me come here. So here you can see initially within the Docker container it is going to install Trivy, and next here you can see after installing Trivy it is going to show you the version and it is going to check for all the severe and high vulnerabilities for all the microservices, guys. Okay. And let me come down. So here you can see this is the user service Docker image, and let me come up. So this is the user service and this is the report for that. Now let me come down. And here you can see this is the search service report. So this is the search service. Now let's come down. It is going to generate a very big report, guys. Okay. Now here you can see this is the booking service report. Let's come down. Let's go for another microservice. And this is the payment microservice report. So this is the entire report. And let's go for other microservice, and this is the notification service, guys. Okay. So let's come to bottom of the page, and here you can see pipeline is also green, guys. Okay. So let me go up and let me show you everything. So after scanning all these Docker images, it is going to update our helm values.yaml file, guys. Okay. Let's come down. So here you can see using set command, it is going to update all the images inside this helm values.yaml file, guys. Okay. Basically it will update only these tags. Okay. Let me open this helm chart. So instead of latest, it will update this image tags and it will package this helm chart and it will push this helm chart to GCP Artifact Registry, guys. Okay. And here you can see after updating, we are going to just echo this values.yaml file, and here you can see it is updated to 1.0.3, and it is going to package this helm chart and it is going to push this helm chart to GCP Artifact Registry, guys. Okay. Now let's come down, and here you can see it is going to log into our GCP Artifact Registry, and next it is going to push this Helm chart to GCP Artifact Registry. Next it is going to connect to our GKE cluster using our service account JSON. I will explain you about this project ID and service account JSON while writing this Jenkins pipeline, guys. Okay. And finally, it has connected to our GKE cluster using this command with our GCP service account JSON file. And so these are the two nodes available inside our GKE cluster. And next here you can see it has connected to our Helm repository, and it has pulled this Helm chart, and it has upgraded this Helm chart, guys. Okay. So now the revision is 2, and here you can see all the pods will be recreated, guys. Okay, with the new tags. So here you can see these are all the pods, and these are the services, and this is the gateway, and these are the gateway. Okay, and this is the HTTP routes, and this is the stateful set, and these are the config maps, and these are the secrets, and this is the HPA, guys. Okay, and after completing all these stages, right, it is going to run Docker system prune inside our Docker container, guys. Okay, so here you can see it has removed nearly 583.1 MB. And pipeline complete status, it is going to show you the build number of the pipeline and current image tag and Helm chart version, and this is the cluster name, and this is the namespace, which is travel booking, and pipeline is successful, guys. Okay, so this is how it is going to show you everything. Now if you want to see this 1.0.3 tag, you can directly describe this. Okay, so here you can see after completing this build, it is going to delete that pod, guys. Okay, agent will delete that pod. Okay, so here you can see that pod has deleted. So this is the main Jenkins agent pod. So this is how it will work inside Jenkins. Now let me run. Before that, let me do ls -a grep travel. Okay, let's run like this. It will show you the travel booking Helm chart, and here you can see travel booking. So here we need to focus on revision. So here you can see revision is 2, guys. Okay, so now let me run kubectl get pods -n travel booking, and it is going to show you all the pods inside travel booking namespace. So here you can see all the pods were recreated. Apart of Postgres and Redis, all the microservices pods were recreated, guys. Okay, with latest tag, which is 1.0.3. So if you want to check that, you can directly describe any single microservice, guys. Okay, that means single pod kubectl describe pod, and you can directly provide the pod name and -n travel booking. And here you can see we need to see tag as 1.0.3. So here you can see 1.0.3 tag. Okay, so this is how it is going to deploy our travel booking application to our GKE cluster base. Okay, so we automated everything. So now let's focus on monitoring. So let me open GitHub repository, and let me close this Helm. And again, if you want to see this Helm custom value, sorry, Jenkins custom values.ml file, you can find that inside Jenkins and custom values.ml, guys. Okay, and by following this jenkins.md file, you can directly install Jenkins inside your GKE cluster. Okay, so I will explain you about this README file while setting up Jenkins inside our GKE cluster, guys. Okay, so let me remove this, and let me remove this. So now let's discuss about monitoring part. Let me open monitoring.md, and let me open this. Okay, now let's discuss about monitoring part. For monitoring, I have set up full Prometheus and Grafana stack using Helm. So Prometheus grabs metrics for every Go backend service for every 15 seconds through the /metrics endpoint. Each service exposes HTTP request count, response time, error rates, and active connections. And the payment service additionally exposes business metrics like successful payments, failed payments, and total amount processed. I have also created service monitor resources that tell Prometheus which service to scrap, and Prometheus auto discovers the pod. And I have also set up 6 alert rules, and it alerts when a pod goes down, or when CPU or memory usage exceeds 80%, and when HTTP error rate spikes about 5%, and when response time exceeds 2 seconds, or when a pod keeps restarting, guys. Okay, so now let me open Grafana dashboard. So here you can see this is the Grafana dashboard. So here Grafana has 6 pre-built dashboards, like an overview dashboard shows the entire application health, and one dashboard per service with the detailed metrics, guys. Okay, so if you want to see all those dashboards, you can directly open these dashboards. And here you can see this is the booking service dashboard. So this booking service is created on the travel booking namespace. Okay, So I will show you this dashboard later. First, let me show you overview dashboard. So here you can see travel booking hyphen overview. And here you can see these are all the other services like notification dashboard, payment service dashboard, and this is the overview, and this is the user service dashboard, and this is the search service dashboard, and top we have booking service dashboard guys. Okay, and finally this is the overview dashboard for our travel booking application. Let me open this and let me keep for last 3 hours, and I want to refresh for every 5 seconds case. Okay, so here you can see request per service. So here you can see it is showing everything in live, and response time, and GKE cluster CPU usage, and GKE cluster memory usage guys. Okay, it is going to show you everything in live. Now let me here you can see it is showing success rate as 100% guys. Okay, because every transaction is success guys. Okay, so now let me select here dashboards. Now let me select here user service. So if you want to see user service dashboard, so this is the user service dashboard guys. Okay, so let me keep for 3 hours, and for every 5 seconds I want to refresh. Okay, so this is the request rate, and this is the error rate, and this is the response time, and these are the active connections, and this is the login rate, and this is the pod CPU usage guys. Okay, it is going to show you everything in live guys. Okay, so similarly, if you want to check for other service, like let's check for notification service, so this is the notification service dashboard. Let me select for 3 hours and for 5 seconds, and here you can see notifications and for per minute. So this is the dashboard, and queue size and emails and per minute. Okay, it didn't send even single email, so that is the reason why here it is showing 0. Now similarly, let me open other one, which is payment service, and I want to check last 3 hours payments guys. Okay, so here you can see it is showing live total amount, and here you can see payment service payment success rate is 100% because we don't have a single failed payment, and total amount we got from travel booking application is 3,737 USD, and here you can see payments per minute and response time, pod memory usage. Okay, so you can see everything here guys. Okay, it is going to show you live amount in this payment service dashboard guys. Okay, so this is one of the benefit. So now let me open search service. So this is the search service dashboard, and let me keep for last 3 hours and 30 seconds. Okay, so this is the search service queue per minute, and this is the response time. Yes, okay. So mainly in payment service, it is going to show you the live payments case. Okay, it is going to show you live amount for our travel booking applications case. Okay, all the dashboards are working fine, and I just tested everything guys. Okay, so this is the booking service dashboard finally. Okay, and if you want to see overview about this travel booking application, this is the entire overview of our travel booking application dashboard case. Okay, now let me open this alert manager. Okay, so alert manager handles the alert notifications, and it can be configured to send alerts to the Slack, email, or pager duty when something goes wrong guys. Okay, and everything runs inside the same GKE cluster like Prometheus, Grafana, alert manager, and all these three are accessible via domains at slash Prometheus, slash Grafana, and slash alert manager through the gateway load balancer guys. Okay, so here you can see Grafana I was accessing at vijay.in slash Grafana, and Prometheus I was accessing with vijay.in slash Prometheus. Similarly, Alert Manager I was accessing with vijay.in slash Alert Manager. Okay, so this is how it is going to work. Now let me show you entire monitoring stack on GKE cluster. So we deployed this entire monitoring stack using Helm. So let me show you this everything. Let me open this GKE terminal, and let me clear the screen. Now let me run this command kubectl, or else okay. Let me do helm ls hyphen a, and again it is going to show all the helm charts in all the namespaces. Now here we need to focus on monitoring namespace guys. Okay, because in monitoring namespace we installed all the monitoring stack. So here you can see this is the namespace monitoring cube Prometheus tag guys. Okay, so now if you want to see the status, kubectl, sorry, helm status view Prometheus stack, okay, hyphen n monitoring. Okay, and here you can see name is 𝐶ubePrometheus stack and last deployed is on Thursday, May 14th. Namespace it's deployed on monitoring namespace. Status is deployed and revision is 2 and test suite is none, guys. Okay. So now let me show you all the pods, deployment services, replica set, and everything related to this monitoring namespace. kubectl get all hyphen n monitoring, and it is going to show you all the resources related to this monitoring, guys. Okay. So here you can see these are all the pods inside monitoring namespace. And here you can see this is the alert manager pod, and this is the Grafana pod, and this is the Prometheus pod, guys. Okay. And here you can see this is the alert manager service, and this is the Grafana service, and this is the Prometheus service. So similarly, this is the daemon set, and these are the deployments, and these are the replica sets. Okay. It is going to show you everything, and this is the stateful set, guys. Okay. Now, let me clear the screen. So now if you want to see service monitors, so we also created service monitors inside travel booking namespace. Let me show you that kubectl get service monitors hyphen n travel booking. Here you can see these are the service monitors. So booking service service monitor and notification service monitor, payment service monitor, search service monitor, and user service monitor, guys. Okay. Similarly, if you want to see Prometheus rules, you can directly run this command kubectl get Prometheus rules hyphen n monitoring. Okay. So we created this on monitoring namespace, and here you can see travel booking alerts. Okay. So this is the one. Now, if you want to see config maps, kubectl get config maps hyphen n monitoring. So config maps is nothing but these are all the dashboards, guys. Okay. So here you can see search service dashboard and user service dashboard and payment service dashboard and overview dashboard, notification service dashboard, guys. Okay. And booking service dashboard. Okay. So we created this as a config map inside this monitoring namespace. So I will explain you about this in detail while setting up this monitoring stack inside our GKE cluster. Okay. So now let me open Prometheus and let's run few of the queries. Before that, let me open this and let me open here prometheus.md file. Okay. You can directly close this everything and you can directly open this monitoring and monitoring.md. Okay. Now let me run few of the Prometheus queries. Let me come down. Okay. So here you can see if you want to see all the targets are up or not, you can directly run up inside Prometheus, guys. Okay. Let me come here. You can directly open Prometheus and here you can see if you select here up and if you select here execute and here you can see everything is running. So similarly, let me open this and if you want to see HTTP request handled by user service, you can directly run this query. Okay. Let me copy this, paste it here and execute. Okay. And here you can see it is showing the data. So similarly all the queries here it will work, guys. Okay. So if you want to see successful payments, you can directly run this query inside Prometheus successful payments and execute. Okay. So here you can see we have successful payments. So similarly if you want to see failed payments, right now we don't have even single failed payment, guys. Okay. Now, if you want to see total money processed, you can directly run this query and execute. And here you can see everything something like this, guys. Okay, you can directly run this queries, guys. Okay, so we'll discuss in detail while setting up monitoring stack inside our GKE cluster. So this is about monitoring. So finally, let's discuss about DNS, HTTP and HTTPS. And for DNS, I registered a domain on GoDaddy and pointed it to the gateway static IP address using a record. And the static IP is created by Terraform, so it will never change even if we redeploy this. Okay. So now let me show you GoDaddy and gateway. Before that, let me select here kubectl get gateway hyphen n travel booking So it is going to display Kubernetes gateway, guys. Okay. So here you can see this is the gateway we created. So I just associated this gateway IP to GoDaddy, guys. Okay. So let me open this GoDaddy. So here you can see this is my domain name, which is vijayagidithuri.in, and I just pointed with a record, guys, 34.54.29.31. And let me come here. So here you can see 34.54.29.31. If you want to check in detail, you can directly run this command ns lookup vijayagidithuri.in. Okay. So now here you can see same IP address it is showing this. Okay. So we just associated this gateway IP with our domain name. So initially we created this static IP using Terraform, and we just associated that name to this gateway, guys. Okay. So let me show you this static IP address. So you can directly jump on to VPC. Let me open VPC and IP addresses, and inside this you can find that IP address for the gateway. So here you can see travel booking IP. So this is the IP we created, guys, for the gateway load balancer. Okay. So now let me open this. So basically this gateway API acts as the entry point. It creates a Google Cloud load balancer, and all traffic comes through the single load balancer and gets routed to correct service based on URL pathways. Okay. And the slash goes to the front end, and slash API slash users goes to the user service, and slash Jenkins goes to the Jenkins service, slash Grafana goes to the Grafana service, and so on, guys. Okay. Already I shown you those things. So if you want to check for load balancer, you can directly open this Google Cloud Console and search for load balancing. And let me open this. So when we create Kubernetes gateway, automatically that gateway will create a load balancer. So here you can see this is the application load balancer it has created, guys. Okay. So this is the application load balancer it's created. Okay. So now let me open this. Now let me open set manager documentation. Let me open this. So you can directly find this HTTPS setup guide inside this docs folder. So for HTTPS, I installed set manager on GKE using Helm, and set manager automatically requests a free SSL certificates from Let's Encrypt, and it proves domain ownership through a HTTP 01 challenge, guys. Okay. So Let's Encrypt sends a request to special URL on our domain, and set manager creates a temporary port that responds with a verification token. And once it's verified, Let's Encrypt issues the certificate, guys. Okay. So basically, the certificate is stored as a Kubernetes secret, and the gateway uses it to terminate TLS on port 443, guys. Okay. And have also set up HTTP and HTTPS redirections. So every HTTP request gets a 301 permanent redirect to HTTPS. So all traffic is encryption. So the best part is the certification is auto renews. Let's Encrypt certificates are valid for 90 days, and set manager automatically renews them after 30 days before expiry, guys. Okay. So here so zero manual interventions is needed, guys. Okay. So now let me show you this inside our GKE cluster for this set manager thing. Let me open this GKE and let me do ls-a. Now it is going to show you all the Helm charts inside this GKE cluster. So we need to see set manager one. And here you can see this is the set manager Helm chart. So we installed this on set manager namespace, guys. Okay. So if you want to check the status, you can directly run this command helm status set manager -n set manager. Okay. So it is going to show you the status of this set manager Helm chart. So here you can see name is set manager, last deployed on Friday, May 15th. Namespace is deployed on set manager. Status is deployed, revision is 1, and test suite is none, guys. Okay. So now let me show you all the running Kubernetes resources for this set manager. Let me run this command kubectl get all -n set manager. Now it is going to show you all the Kubernetes resources for this set manager, like pods, deployment services, and everything. So here you can see these are the set manager pods, and this is the set manager services, and these are the deployments, and these are the replica sets. Okay. So if you want to see cluster issuer, you can directly run this command kubectl get cluster issuer. So here you can see let's encrypt prod cluster issuer, guys. Okay. So finally, if you want to see certificate, you can directly run this command kubectl get certificate -n travel booking. So we created this certificate inside this travel booking namespace. And here you can see travel booking TLS and its status is true. Okay. So we created last 19 hours ago, guys. Okay. So end of the day, we can successfully able to access with HTTPS connection, guys. Okay. So let me click on this. So here you can see it's HTTPS. And if I select this, connection is secure. And if you want to see the TLS certificate, so this is the certificate for that, guys. Okay. Similarly, let me open Jenkins. So username is Vijay, and let me provide the password and sign in. And here you can see this is the Jenkins login page. So we can able to access Jenkins with HTTPS. So here you can see HTTPS vijayagudturi.in/Jenkins, and this connection is secure. So similarly, Grafana connection is secure, and we can able to access with https://vijayagudturi.in/grafana. Similarly for Prometheus, so here you can see connection is secure, and https://vijayagudturi.in/prometheus. So finally for alert manager also we are going to secure this case. Okay, https://vijayagudturi.in/alert manager, and you can see connection is secure. Okay. So all these applications we directly deployed on our GKE cluster instead of maintaining any other virtual machines, guys. Okay. So I created this entire application in a real-time approach. Okay. So now let's destroy this entire application and let's do this everything from scratch, guys. Okay. So for that, let me come here. So I'm going to delete GKE cluster manually because I just created GKE cluster manually from the GK Google Cloud Console. So other resources I created using Terraform. So let me select here clusters. So once when we delete this single cluster, right, we cannot able to access all these guys. Okay, like we cannot access travel booking application, we cannot access Jenkins, we cannot access Grafana, Prometheus, and Alert Manager, guys. Okay, everything will be destroyed because all the resources we are running inside this GKE cluster. Okay, so now I'm going to select this and I'm going to delete this, and let me provide cluster name travel booking cluster and paste and delete. Okay, so now this cluster will delete after 5 to 10 minutes. I will destroy this all the resources and let's start the setup from scratch, guys. Okay, all the GCP resources were destroyed successfully. So now let's start this project from scratch. Initially we need to clone this travel booking repository to local. So already I have this repository in my local, so I'm going to use that repository. Next, we need to create GCP infrastructure like VPC, subnets, firewalls, static IP, artifact registries, and GKE cluster. So you can find all those Terraform scripts inside this GCP-Terraform directory. So let me open this modules. So here you can see artifact registry module, firewall module, GKE module, static IP module, and VPC module, guys. Okay. So you can directly follow this documentation, which is readme.md inside GCP-Terraform. So here you can see travel booking GCP Terraform infrastructure, guys. Okay. So it is going to create VPC network, subnet, firewalls with SSH, HTTP and HTTPS. And next it is going to create third firewall rule for internal communication. And next it is going to create for health checks. Next it is going to create GKE cluster, GKE node pool, artifact registry, static IP for gateway, guys. Okay. So you can directly follow this documentation. But in this video, I'm not going to create GKE cluster using Terraform due to lack of resources, guys. Okay. So now let me open these docs and let me open this terraform.md. So let me come down. So these are the prerequisites. Initially in your local, you need to install Terraform, and next you need to install gcloud CLI, and you need to have a GCP project with building enable, and you need to have a GCS bucket for Terraform state storage because we are going to store all the Terraform state inside this Google Cloud Storage bucket. And next you need to create a GCP service account JSON key with these rules, guys. Okay, so compute engine admin, artifact registry admin, storage admin, service account user, guys. Okay, so now let's do this everything, and after this you need to update project ID and credentials and region inside terraform.tfs. Next, you need to update your cloud storage bucket name inside provider.tf, guys. Okay. So initially, let's create Google Cloud Storage bucket and let's update this name, guys. Okay. So before that, here you can see, let me come out from this directory and let me do ls. And here you can see travel booking. Already I cloned this repository. Let me enter into this repository travel booking and let me do ls. And here you can see GCP-Terraform. So we need to redirect to this directory and let me do ls. And first we need to update cloud storage bucket inside this provider.tf, guys. Okay. So vim provider.tf. So here you can see bucket GCS. So backend, we are going to store our Terraform state file inside this Google Cloud Storage bucket. So you need to create bucket with any of the name, but that name you need to update here, guys. Okay. So I'm going to create with this same name. Let me copy this. Okay. And let me open my Google Cloud. So you need to select here these three lines and directly open cloud storage, guys. Okay. So this is the service and directly select here buckets. So it's similar to AWS S3 and Azure Blob Storage, guys. Okay. So directly select here create and you need to provide bucket name. So I'm going to provide that same bucket name, which is travel booking -GCS bucket. And let me select here continue and location type. I'm going to select here US and continue. And you can directly select continue and continue and create, guys. Okay. So now this is going to create a Google Cloud Storage bucket. So inside this bucket, we are going to store our Terraform state file, guys. Okay. So here you can see right now we don't have even a single file. So while creating this Terraform script, right, it is going to store Terraform state file inside this Google Cloud Storage bucket. So now let me open this documentation. Next, we need to update project ID. So you can directly find this project ID here, guys. Okay. So you can directly drop down this and here you can see this is the project ID. So I'm going to copy this project ID and we need to update this project ID inside terraform.tfrs file. So let me come out from this file and vim terraform.tfs. Okay. So already this is my project ID, guys. Okay. So let me remove this project ID and let me copy this project ID once again. So this is my project ID. Now let me open this and let me paste it here, guys. Okay. So region, I want to create all the Terraform scripts inside US Central one. That is up to your wish. If you want to create in some other region, you need to update this, guys. Okay. So now we need to update this credentials file, which is keys.json. So let me come out from this file and let me do ls. And here you can see this is the IAM service account keys.json file. So let me delete this file, guys. Okay, I will explain you how we can delete this service account JSON. First, let me remove this keys.json and vim keys.json. Okay, so I'm going to create a new file. Now let's download this IAM service account JSON file. So you can directly select here IAM and directly open here service accounts. And here right now, this is my old test SEA service account JSON file. And this is the default service account JSON, which comes with the compute engine default service account. So now I'm going to create a new service account. Directly select here create service account and name. Let me provide name like travel booking -SEA. Okay, travel booking service account and create and continue. Now here we need to update our roles. So basically you need to update these roles, guys. Okay, compute admin, artifact registry admin, storage admin, service account user. But for video purpose, I'm going to provide owner permissions, basic and owner. Okay, and let me select here continue and directly select here done. Okay, so now here you can see it's created travel booking service account. So if you want to see all the permissions for this service account, so you can directly jump onto IAM. So in IAM tab, you can directly see all the permissions. So here you can see travel booking SEA. We provided owner permissions, guys. Okay. So if you want to update more permissions, you can directly select here edit and you can directly select add another role. For example, if you want to provide artifact registry permissions, you can directly select artifact registry. Here you can see artifact registry repository administrator and directly select here save. Okay. automatically it will add this role, guys. Okay, but for now we just directly provided owner permissions, so that permission is not required, guys. Okay, so now we need to download IAM service account JSON file, and we need to update that service account JSON file inside our Terraform scripts. Okay, so this is the travel booking service account we created. Now let me open this, and you need to directly select here keys and directly select add key, create new key, and you need to select key type as JSON and create. So now it is going to download a JSON key. So it's downloaded. Let me close this and let me open my file manager and downloads. And here you can see this is the one. Let me open this. So here you can see travel booking SCA. Okay, so this is the type, which is service account. So basically this is the project ID, and this is the private key ID, and this is the private key, and this is the client email, and this is the client ID, this is the authentication URL, this is the token URL, guys. Okay, so basically using this IAM service account JSON file, Terraform will create all the resources inside Google Cloud, guys. Okay, so now I'm going to copy this. Let me open this and let me paste it here, guys. Okay, now let me save this, and we are referring this keys.json inside terraform.tfs, guys. Let me cat this file terraform.tfs, and here you can see credentials file we are passing as keys.json. This is the file, guys. Okay, so using this file, Terraform will connect to our Google Cloud account, and it is going to create all the GCP resources, guys. Okay, so now let me open this documentation. All these steps were completed. So next we need to set this credentials environment variable using this keys.json file. So already I have set up this one, guys. Okay, so let me copy this and let me paste it here. Okay, so here you can see I just mounted to this path. So now let me cat this file. Let me cat this. So here you can see it's updated successfully, guys. Okay, so now we need to run this terraform init command. So let me clear this screen. Let me do ls. Okay, we are inside this gcp-terraform directory, terraform init. So here you can see it is initializing the backend. So let me open this travel booking, and let me select here cloud storage and buckets, and let me open this travel booking GCS bucket. Inside this, now we need to see state file, guys. Okay, so here you can see terraform and state. Okay, so inside this state you can find default tf state, guys. Okay, so this is how this terraform it works. So now let me open this documentation. Now I'm going to create only 4 modules, which is module VPC, module firewall, module artifact registry, and module static IP, guys. Okay, because I'm not going to create GKE cluster using Terraform, because I don't have resources to create GKE cluster using Terraform, guys. Okay, so if you want to create including GKE, so you can directly run Terraform plan, and you can directly run Terraform apply, guys. Okay, automatically it will create all these resources. But in this video, I'm not going to create GKE cluster using Terraform. But this Terraform scripts for GKE is working, guys. Okay, so now let me open terraform.md. Now let me copy this command terraform plan. Now it is going to show all the resources what it is going to create, and here you can see it is going to create 8 resources. So now let me apply this. So next we are going to create all the terraform resources using terraform apply command. Part of GKE we are going to create everything, guys. Okay, let me paste it here, or else up arrow, and let me directly select here apply. Now it will create all the resources using Terraform, guys. Okay, with our IAM service account JSON file, and we need to provide here yes. So it started creating. Okay, so it started creating static IP, it started creating VPC, it started creating artifact registry. Okay, and it started creating VPC. Okay, static IP. So meanwhile, let me open Google Cloud and let me navigate to VPC network and VPC networks. So here you can see travel booking VPC it's created, but okay, firewall rules also it's created, guys. Okay, so let me open this. and subnets. And here you can see it's created travel booking subnet on US Central 1 with this CIDR. Next, firewalls. It is going to create 4 firewall rules. Okay, so here you can see it's created 4 firewall rules. Now, let me navigate to, or else first let me check for static IP. Let me select your IP addresses. And here you can see travel booking IP it's created, but in use by none. Okay, so we are going to use this IP address for our Kubernetes gateway API, guys. Okay, now let me select Artifact Registry. So in this Artifact Registry, basically we are going to store our Docker images and we are going to store our Helm charts, guys. Okay, repositories, select a project. Let me select my first project. Okay, and repositories. Mm, let me open it once again. Artifact Registry. Okay, it's redirecting to some different Google Cloud account. Let me close this entire tab or else. Okay, so this is the actual Google Cloud account I'm using. Let me search for Artifact Registry, and here you can see travel booking. It's created, guys. Okay, so now let me come here, and here you can see all the resources were created. So this is the Artifact Registry URL. It's created. This is the static IP created. Subnet it's created, and VPC it's created, guys. Okay, so all the resources were created a part of GKE. So now I'm going to create GKE cluster manually from Google Cloud Console. So for that you can directly follow these steps, guys. Okay, so let me copy this name. So with this name I'm going to create this GKE cluster. You can directly open GKE. So Kubernetes engine, guys. Okay, I'm going to open this in a new tab, and let me select here clusters and directly select here create. And here I'm going to create standard cluster. So configure. So now we need to provide cluster name. So this is the cluster name, travel booking cluster. And I'm going to select here zonal, and zone I'm going to create on US Central 1A. And you can leave this everything by default, and fleet registration you can leave this by default, and default pool. So this is the default pool name, and number of nodes is 2. I'm going to enable cluster autoscaler, and total limit minimum is 2, maximum is 4. Okay, so this is enough. Now let's come down and directly select here nodes, and you can directly come down. When it comes to machine type, here I'm going to select E2, and let me drop down this. I'm going to select here standard. Here I'm going to select E2 standard for this. Okay, so each node it is going to create with 4 CPUs and 16 GB of memory, guys. Okay, so I'm going to select storage as 60 GB. So each node it is going to create with 60 GB of SSD. So I'm going to select here standard persistent disk. Okay, now let's come down, and you can leave this networking security metadata by default and directly jump on to networking. And here VPC, so previously we created this travel booking VPC using Terraform, right? So you need to select this VPC. Next we need to select this subnet and directly select here create. Okay, so now it will take around 5 to 10 minutes to create this GKE cluster, so we need to wait for some time. So here you can see we followed all these steps, guys. Okay, next, after creating this cluster, we are going to connect to this cluster, and we are going to enable this gateway API for our GKE cluster, guys. Okay, so I will explain you this later. Meanwhile, let's wait for some time. So here you can see GKE cluster has been created successfully after 5 minutes. So now let me select here nodes, and here you can see number of nodes is 2. So now let me select here compute engine and virtual machines, and here you can see both the nodes are in ready state. So now let's connect to this GKE cluster from our local. Before that, let me do ls. Let me connect to my Google Cloud account. So let me copy this command. gcloud auth activate service account -key -file is equal to, here we need to provide our IAM service account keys.json file. So this is the file is okay, which is keys.json, keys.json. Okay. So here you can see activated service account credentials for travel booking SE. Okay. So using this service account JSON, we are going to connect to our Google Cloud account. Next, we are going to list all the projects inside this Google Cloud account. Let me run this command, gcloud projects list. It is going to list all the projects, and here you can see this is the project, my first project, guys. Okay. So let me show you this. So here you can see my first project. Now we need to set this project ID. So let me copy this and let me open this terminal. gcloud, let me see this command once again. gcloud config set project. Okay. gcloud config, sorry, set project, and you need to provide your project ID. So basically this is the project ID, and paste it here and hit enter. So now this command will connect to this GCP project. Okay, updated property. Next, we need to connect to our GKE cluster, guys. Okay, so if you want to get this command, you can directly open your GKE tab. So basically this is our GKE cluster, right? So basically this is our GKE cluster. You need to open your cluster and you need to select here connect and copy this command and open your terminal and directly, okay, it's not copied properly. So let me open this. You need to copy this and you need to paste it here, guys. Okay, so now it will connect to this GKE cluster. So it's connected successfully. kubectl get nodes -oy, it is going to display all the nodes of this GKE cluster, and here you can see these are the two nodes and it's created last 4 minutes ago, guys. Okay, so now we need to enable gateway API for this GKE cluster, because so in this project we are going to use ingress controller as a Kubernetes gateway API. So for that you need to run this command. So let me copy this entire command, copy this, or else let's directly update this name, guys. Okay, so let me open GKE. So this is the cluster name, travel booking cluster. Copy this and paste it here. So we need to update the project ID also. Let me copy this. So basically this is the project ID. Okay, so copy this project ID and replace this one, guys. Okay, so now let me copy this entire command. So now we are going to enable gateway API for our GKE cluster, guys. Okay, let me clear the screen. kubectl get nodes. Okay, kubectl get nodes. Now let me run this command. So basically this command will take around 5 to 10 minutes to enable gateway API for our GKE cluster, guys. Okay, so let's wait for some time. So here you can see gateway API is updated successfully. So now let's check all the gateway classes. So you can directly run this command, kubectl get gateway classes. It is going to show all the gateway classes, guys. Okay, so here you can see all the gateway classes has been created last 2 minutes ago. So now let's install Jenkins on our Google Kubernetes engine using Helm. So you can install Jenkins by following jenkins.md file. So that is available inside Jenkins directory, guys. Okay, so let me show you that, or else let me open directly here. Let me close this. Now This is the jenkins.md, and let me keep it like this, guys. Okay. So by following this jenkins.md file, you can directly install Jenkins on our Google Kubernetes engine. So before installing Jenkins, first let me explain you about what actually Jenkins is. So basically, Jenkins is an open source automation server used for CI/CD, which is continuous integration and continuous deployment. It automatically builds, tests, and deploys our application whenever you push code changes, guys. Okay. So in our setup, we are running Jenkins inside our Google Kubernetes cluster as a Kubernetes pod, and agent workers are dynamically created as pods. So they can spin up when a job runs and gets destroyed when if it's done, guys. Okay. So each agent pod creates with multiple containers like Docker, Node.js, Go, Helm, and gcloud. One container for each task, guys. Okay. So now let me explain you about Jenkins custom values.ml file. So you can find this Jenkins custom.ml file inside this Jenkins directory itself, guys. Okay. So let me close this. So basically, this file contains how Jenkins runs inside our GKE cluster. So at the top, we set up admin username and password like Vijay and Vijay at the rate 123, which is what we use to log into Jenkins. We also disable self registrations, so nobody else can create accounts, guys. Okay. So the main section is Kubernetes Cloud Config. So this tells Jenkins that when a pipeline runs, it should create a temporary pod in our Google Kubernetes cluster as a build agent. And the pod template is named as travel booking with the label travel booking. So basically this matches agent label equal to travel booking line in our Jenkins file, guys. Okay. So here you can see inside templates name we are going to use travel booking and label we are going to use this travel booking, guys. Okay. So let me show you inside Jenkins file. So if I open this Jenkins file, so here you can see agent label we are going to use as travel booking, guys. Okay. So once again, let me open this values.ml file and custom values.ml. Okay. So basically each agent pod has 7 containers inside it. So the JNLP container handles communication between agent and Jenkins controller. And this is always required, guys. Okay. And the Docker container runs in privileged mode with Docker Scout mounted. So we can build Docker images inside pod. And Golang container has Go 1.21 for testing our backend services. And the Node.js container has Node.js 20 for testing the frontend. And the Helm container has Helm for packaging and deploying Helm charts. And the gcloud container has Google Cloud SDK for authentication with GCP and to connect to our GKE cluster. And finally, and the Canico container is alternate to image builder if we ever need to build images without Docker, guys. Okay, so you can find that Canico here. So here you can see this is the JNLP, Canico, and Node.js, and this is the Golang container, and this is the Docker container, and this is the Helm container, and this is the gcloud container, guys. Okay, so now let's come down. Next, it is going to install 24 plugins, and let's come down. And Jenkins is configured as /Jenkins path with Jenkins URI prefix. And this is how it works behind our gateway, guys, at vijay-git3.in/Jenkins. Here you can see. And the service type we are going to create with node port. So it's accessible directly via node IP if needed, guys. Okay. Now let's come down. So we also use 15 GB persistent volume with GKE premium SSD storage class. This means all Jenkins data like job configurations, builds history, and plugins survives even pod restarts, guys. Okay. And finally, Jenkins runs under service account called CD Jenkins, guys. Okay. So now let's set up this Jenkins inside our Google Kubernetes engine by following this jenkins.md file. Let me open this file inside this GitHub. Let me come down and let me select here Jenkins, and here I'm going to select jenkins.md. This is jenkins.md. So already I have this custom values.ml file inside my repository. Let me do ls and let me come out from this gcp-terraform directory and let me do ls, and here cd jenkins and ls, and here you can see custom values.ml file, cat custom values.ml file. So here you can see this is the entire custom values.ml file we are using to install Jenkins our GKE cluster case. Okay, so now let me open this. Initially we need to add Jenkins Helm repository. First let me open this terminal And let me do Helm repo ls. Already, I think I have these repositories, guys. Okay, so Jenkins, Prometheus, and Jetstack. Okay, let me remove these three. Helm repo remove, Jenkins, and Helm repo remove Jetstack, Helm repo remove Prometheus hyphen community. Okay, it was removed successfully. Helm repo ls. Okay, so right now we don't have even single Helm repository. So now I'm going to add this Helm repository. Let me copy this and let me paste it here. Now let me run this command Helm repo ls, and here you can see repository has been added successfully to our GKE cluster. So now let's verify the repository. Let me copy this and let me come here. Okay, let me copy this once again, paste it here, and here you can see these are all the chart versions available right now, but I'm going to pull this chart which is 5.8.53. So let me copy this. Initially it is going to pull this Jenkins Helm chart. Next it is going to extract this Helm chart case. Okay, so let me copy these commands and let me paste it here. Okay, let me cancel this. Let me copy these commands once again and let me paste it here. So initially it is going to pull this Jenkins version 5.8.53 Helm repository, and next it is going to extract this and it is going to list all the files inside this Jenkins directory, guys. Okay, now let me do ls. So here you can see this is the repository we pulled and we extracted to normal folder, guys. Okay, so now let me enter into this Jenkins directory and ls, and here you can see you can find all the YAMLs related to Jenkins, and inside templates directory you can find all the YAML manifests for this Jenkins, guys. Okay, so now let me come out from this directory and let me come out once again and let me do ls. So now let me open this. Now if you want to dry run this using your custom values.ml file, you can directly copy this command and you can directly run this here, guys. Okay, so here you can see Helm template, and this is the name we are going to provide Jenkins, and this is the folder name which is Jenkins and -f custom values.ml. Okay, using this file we are going to render this, guys. Okay, let me hit enter. So here you can see it is going to show us all the templates, guys. Okay, so this is the Jenkins test ml and this is the Jenkins config ml, and let me come up. Basically it is going to show you nearly 35 plus Kubernetes MLs for Jenkins case. Okay, Jenkins controller stateful set ML, and we are going to override few values using this custom values.ml file, guys. Okay, so we are passing these values into that Helm chart, guys. Okay, so now let me open this. Now I'm going to install this Jenkins Helm chart using this custom values.ml file. Before installing this, let me run this command helm ls-a. So right now we don't have even single Helm chart, guys. Okay, so now I'm going to install this Helm chart. So this is the name I'm going to provide Jenkins, and this is the folder name which is Jenkins and -f custom values.ml file, guys. Okay, so using custom values.ml file, I'm going to install Jenkins on default namespace, guys. Okay, now I'm going to hit enter. So now it is going to install Jenkins on our Google Kubernetes engine, guys. Okay, let's come down. So here you can see I have written in detail. So Helm install installs a new Helm release, and Jenkins. So first name is the release name and the second name is the chart directory name, guys. Okay, and -f is nothing but this is our custom values configuration. Okay, so now let me come here. So here you can see it's installed successfully. So the name is Jenkins, last deployed on Friday, May 15th, and namespace it's created on the default namespace, status is deployed, and the revision is one. So the username is Vijay and password is Vijay@123. And if you want to check that password, and you can directly open this and cat custom values.ml, and if you go up you can find the password. Okay, so username is Vijay and password is Vijay@123. If you want to create with some different username and password, just update these values, guys. That's it. Okay, so now Let me run this command helm ls-a. It is going to show you all the Helm charts in all the namespaces. So here you can see it's deployed successfully. Now kubectl get pods. So we created this Jenkins on the default namespace case. Okay, so here you can see ready 1 by 2 because one container is up and one container is still in the creating state. Let me keep hyphen watch. Within some time it will be ready, guys. Okay, here you can see 2 by 2. So meanwhile, let me come here, and if you want to see these Jenkins values, you can directly run this command. Let me cancel this and let me run this command helm helm get values, and the chart name is Jenkins, and it is going to show you all the values, guys. Okay, so using these values we install Jenkins on our Google Kubernetes engine, guys. Okay, so let me run this command kubectl get pods hyphen watch. So now here you can see 2 by 2. Now let me open this. Now let me show you all the services for this Jenkins kubectl get all. It is going to display all the pods, deployment services, replica sets in the default namespace, guys. Okay, so here you can see this is the Jenkins pod. So this Jenkins pod is created using this stateful set, and this is the Jenkins service, and this is the Jenkins agent, and this is the default Kubernetes service, guys. Okay, so now we can access this Jenkins UI on web using Kubernetes node IP with this node port, guys. Okay, so now let's try to access Jenkins kubectl get nodes hyphen o wide. Okay, so here you can see these are our two Kubernetes nodes, and using any of the node external IP and with this node port you can directly access Jenkins, guys. Okay, before that we need to provide this node port on GCP VPC firewall rules. So let me open VPC VPC directly open this VPC and open here TravelBooking VPC and firewalls. Now here you need to create a firewall rule. Let me provide the name like Jenkins node port. Okay, now let me come down. So we are going to create under TravelBooking VPC and targets all instances in the network, source IPv4 range 0.0.0.0/0 and TCP. Here we need to provide our node port 31432. Okay, 31432. So now let me select here create. So basically we are providing access for this node port, guys. Okay, now let's try to access Jenkins UI. Let me copy any of the node external IP. Let's try to access all these on incognito window, http:// node IP, and we need to access with node port 31432. Okay, 31432. Continue to site. Okay, so we can't able to access. Let me check this custom values.ml file. So we need to access with /Jenkins case. Okay, because here we just provided Jenkins URI prefix as /Jenkins, right? So you need to access with /Jenkins and the /login. Let's try like this. Okay, so now here you can see it is redirecting to our Jenkins. So username we need to provide Vijay and password Vijay@123. Because if you observe this custom values.ml file, here we just provided username as Vijay and password as Vijay@123. So now let me select here sign in. Automatically it will connect to our Jenkins case. Okay, so it's connecting. Next, let's try to check this pod template. Like, let's try to check this template name with TravelBooking, and let's try to check all these containers like JNLP, Canico, Node.js, Golang, Docker, and Helm and G-Cloud. Okay, so let's check whether this pod template is available inside that Jenkins or not. So you can directly select here Manage Jenkins, and here you need to select Clouds and directly select here Jenkins or template, and here you can see travel booking template. Okay, so template name we just provided travel booking, so it's created. Let me open this, and Pod template name is travel booking. We created on the default namespace. Label we just provided as travel booking. So here you can see label is travel booking. Namespace we created on the default namespace. So namespace is default. Now let's come down, and here you can see raw YAML for the pod. So API version is v1, kind is pod specs, and JNLP, Canico, Node.js, and Golang, Docker, and Helm, and finally G-Cloud. Okay, so it's created with this pod template, guys, successfully. So now let me come out from this and let me open this. So now we can able to access Jenkins, right? So now let me explain you about Jenkins file, guys. Okay, so let me open this VS Code. Now let me come down and Jenkins file. Okay, now let me explain you about Jenkins file. Basically, it defines our entire CI/CD pipeline with 14 stages, and it runs on an agent pod labeled with travel booking, which matches our Jenkins custom values.ml pod template, guys. Okay, so at the top we have environmental variables, and the GCP service account and project ID are pulled from Jenkins credentials, and we set the GKE cluster name, zone, artifact registry path, and image tag with 1.0 followed by the Jenkins build number. So every build gets a unique version, guys. Okay, so now let's come down. So basically this is the very first stage, which is git clone. So pipeline starts by cloning our private GitHub repository using personal access token stored in Jenkins credentials. So basically this pulls all the code into the workspace, guys. Okay, so we need to create a GitHub personal access token, and you need to update in Jenkins credentials, guys. Okay, so I will explain you that later. So the second stage is test go services. So in this stage, it switches to the Golang container. So here you can see container is Golang, and basically it is going to run go mod download and go mod tidy and go wet for all the 5 backend services one by one. So basically this checks for complaint error and code issues before building anything, guys. Okay, so here you can see it is going to enter into user service, and it is going to run go mod download and go mod tidy and go wet. Similarly, it is going to enter into such service, and it is going to run go mod download, go mod tidy, and go wet. And similarly, it is going to enter into booking service, and it is going to run these commands. Similarly, it is going to enter into payment service, it is going to run these commands, and it is going to enter into notification service, and it is going to run these commands, guys. Okay, after successful completion, it is going to display this message like all go services pass it testing. Now the third stage is test frontend. So in this stage, it switches to the Node.js container. So here you can see container is Node.js, and it is going to run npm install on the React frontend to verify all the JavaScript dependencies are valid or not, guys. Okay, so here you can see it is going to enter into frontend repository, and it is going to run this command. After completing, it is going to display this message like frontend dependencies installed successfully, and finally it will come out from this repository, guys. Okay, so the fourth stage is Docker login. So in this stage, it switches to the Docker container, and it is going to authenticate with Google Artifact Registry using our GCP IAM service account JSON key. This allows all subsequent Docker images to push our Docker images to GCP Artifact Registry, guys. Okay. Now from stage 5 to 10, it is going to build all the 6 service Docker images, and next it is going to tag the Docker image with the latest tag as well as with the Jenkins build number. And next it is going to push this Docker images to GCP Artifact Registry. And finally it is going to remove these images, guys. Okay. So here you can see initially it is going to build user service Docker image. Next it is going to tag this Docker image with latest tag. Let me keep like this. Okay. Next it is going to tag with image tag with 1.0.1, something like that, guys. Okay. For example, if Jenkins build number is 1, it is going to tag with 1.0.1. Here you can see image tag we just provided. Let me go up. So image tag here you can see 1.0. Jenkins build number. Okay, so let me come down. For example, if Jenkins build number is 3, it is going to tag with 1.0.3. Next it is going to push this latest image as well as uh, Jenkins build number image to GCP Artifact Registry, guys. Okay, next it is going to remove these images. Okay, similarly, it is going to build for search service. Similarly, it will perform for booking service. Similarly, it will perform for payment service and for notification service and for front end service, guys. Okay, it is going to build one by one. So the 11th stage is Trivy security scan. So in this stage, it will switch to Docker container. Next, it is going to install Trivy on that Docker container. So basically, it's a vulnerability scanner, and it scans all the 6 Docker images for high and critical security vulnerabilities, guys. Okay. So now let me come down. So this is the 12th stage, which is update Helm values file. So in this stage, it uses set command to update all the Docker images. Let me come here, guys. Okay. So it is going to update all the Docker images in Helm values.ml file, guys. Okay. For all the services like for front end, for user service, search service, booking service, payment service, notification service, guys. Okay. It is going to update image tag. For example, if the Jenkins build number is 3, it is going to update with 1.0.3 in helm values.ml file, guys. Okay. And after updating this, it is going to show us updated helm values.ml file. And the 13th stage is package and push helm chat. So in this stage, it runs 3 containers. So the first container is helm, and the second container is gcloud, and the third container is helm, guys. Okay. So now let me go up. So in this container, it is going to package our updated Helm chart. And next, in this container, it is going to authenticate with our Google Cloud account using GCP IAM service account JSON file, and it is going to connect to our project, and it is going to set up this token. Next, in this Helm container, it is going to log into our Helm repository. So in this step, it is going to push this packaged Helm chart to GCP Artifact Registry, guys. Okay. So this is the final stage. So in the final stage, it is going to deploy our travel booking application to GKE cluster. Okay. So let me explain you all these commands. Initially, it is going to authenticate with our Google Cloud using GCP IAM service account JSON. Next, it is going to connect to our project. Next, it is going to install kubectl and GKE auth plugins using this command. Next, using this command, it is going to connect to our GKE cluster, and it is going to check the nodes using kubectl get nodes. And next, it is going to check whether this namespace is created or not, like travel booking namespace. So here you can see variable we are passing like travel namespace, right? Let me go up, and here you can see namespace is travel booking, guys. Okay. So first it is going to check whether this namespace is available or not. So if the namespace is not available, it is going to create that namespace. Next, it is going to log into our Helm registry. Next, it is going to pull our latest Helm chart. Okay. So basically it will tag with 1.0 current build number, right? It is going to pull that Helm chart. Next, it is going to install or upgrade the Helm chart, guys. Okay. If it's the very first time, it is going to install the Helm chart. From the second time, it is going to upgrade the Helm chart with the latest package, guys. Okay. So finally, after deploying, it is going to show us deployed Helm chart and the deployment and the pods and the services and the gateway and HTTP routes and stateful sets and config maps, secrets, HPA, and everything, guys. Okay. So finally, it is going to show us the current Jenkins build number and Docker image tag and Helm chart version and cluster name and namespace, guys. Okay. So it is going to show this everything. So it's around 430 lines of Jenkins file, guys. Okay. So now let's copy this entire Jenkins file, and let me open Jenkins, and I'm going to create a pipeline. So new item. So I'm going to provide name like travel booking pipeline. So I'm going to create pipeline, or else you can directly create multi-branch pipeline, guys. That is also not a problem. So I'm going to select your pipeline and OK. And you can directly come down, and here you need to paste your pipeline, guys. Okay. So I'm going to paste my 430 lines of pipeline, apply and save. So before running this pipeline, we need to store these credentials. Let me open this and let me go up. So we need to store this GCP service account and project ID and GitHub personal access token inside uh, Jenkins credentials, guys. Okay. So let me copy this name, and let me open dashboard and manage Jenkins. And here you need to open credentials, and here global add credentials, and here you need to select secret file, and here ID I'm going to provide GCP service account because same name we just provided on the Jenkins file, guys. Okay. So in this place we need to upload our GCP IAM service account JSON file to Jenkins credentials. So let me provide the same name. So now here you need to select choose file, and this is the file previously I downloaded, right? So I'm going to open this and create. Okay, so now here you can see it's created. Now the second one is project ID. So GCP project ID. So we need to create this as a secret text. Let me copy this name and add credentials, and here secret text, and here ID as GCP project ID, description as GCP project ID. Secret, you need to copy your GCP project ID. So basically this is my GCP project ID, and let me open this and let me paste it here, guys. Okay, so this is my GCP project ID and create. So the third one is we need to create GitHub personal access token. So already I just downloaded my GitHub personal access token. I'm going to use that token, guys. Okay, so this is the personal access token. So if you want to download this, you can directly open your GitHub, and you need to select your profile and directly go to settings and directly select here developer settings and personal access tokens and classic. So this is the token, guys. Okay, so here you need to select generate new token, and you need to select here generate new token classic. So this is how you need to create personal access token. Let me open my repository, travel booking. Okay, so now let me come here. Let me open this, or else before that, let me copy this name, guys. Okay, GitHub-PAT. Copy this, open Jenkins credentials, add credentials. So now kind you need to select with username with password. So username is Vijay Girturi. So this is my GitHub username. So ID GitHub PAT, description is also GitHub PAT. Password you need to provide your GitHub personal access token, guys. Okay, so basically this is my GitHub personal access token. I'm going to copy this. I'm going to paste it here and create. Okay, so all the three credentials are available inside this Jenkins credentials. So now I'm going to run this pipeline, guys. Okay, before running this pipeline, let me open this terminal and Helm less hyphen a. So here you can see a part of Jenkins, we don't have a single Helm chat, right? So now kubectl get pods, sorry, kubectl get pods hyphen watch. Okay, so now currently we have only Jenkins main pod, right? So now when we run this pipeline, when we build this pipeline, this agent pod will create one worker pod, guys. Okay, inside that, using our pod template, it is going to spin up 7 Docker containers, and within the Docker containers, it is going to run this pipeline. It is going to run this entire pipeline, guys. Okay, so now let me trigger this pipeline. So here you can see we have only this single pod, right? So now I'm going to trigger this pipeline. Before triggering this pipeline, let me show you GCP Artifact Registry, guys. Okay, so I just forgot to show you that. You can directly search for Artifact Registry, and let me open this travel booking Artifact Registry, and inside this Artifact Registry right now we don't have a single Docker image, guys. Okay, here you can see no images to display. So after this pipeline is green, right, you can see all the services Docker images inside the GCP Artifact Registry. Now let me select here build now, and let me open this. So now here you can see it will schedule a pod, guys. Okay, so let's, before that, let me open this and let me refresh this page, and here you can see it's currently opening. Let me open this console output, and here you can see started by user Vijay and still waiting to schedule task. Okay, so here you can see it is created a pod. Let me come here. So here you can see travel booking pod. So currently it's in the pending state. So now it's in the container creating state. Almost it will create 7 Docker containers. Like it is going to create all these Docker containers, guys. Okay, let me open this in a duplicate tab. Let me do ls and cd travel booking and Jenkins. Let me do ls cat custom values.ml. Okay, so now it is going to prepare all these Docker containers inside that pod, like JNLP, Canico, Node.js, Golang, and Docker, and Helm, and G Cloud, and everything, guys. Okay, Let me open this terminal and let me come here. So it's 0 by 7. So for the very first time, it will take around 2 to 3 minutes to spin up this pod. From second build, it will complete in less than 10 seconds, guys. Okay, meaning it will come to running state in less than 10 to 15 seconds, guys. Okay, so for the very first time only, it will take around 2 to 3 minutes to spin up this pod. Let me open this. So now here you can see after 116 seconds, this pod came to running state. So now all the builds are in running state, guys. Okay, so here you can see it is using this pod template. So here you can see it is using all the containers like Node.js and Golang and Docker, and let me come down. Okay, so this is the Google Cloud container. Okay, so it is going to use all the containers. Let me come down. Here you can see it has completed all the go test for all the 5 microservices. Initially in the very first stage, it is going to clone this repository. Next, here you can see it has done testing for all the 5 go backend services. Initially it has redirected to user service and it has run these 2 commands. So these are the testing. And next, second service is search service and it has completed this testing. And next, booking service, it's completed. Payment service, it's completed. And notification service, it's completed. And here you can see echo all go backend services pass it testing. So now currently it is doing testing for the front end service. It has redirected to front end folder and it is going to install all these dependencies. And here you can see successfully it is connected to our GCP Artifact Registry. Login is succeed. Now currently it has hunted to user service and it is currently building the user service Docker image, guys. Okay, and it will tag with 1.0.1 because currently build number is 1, right? So that is the reason why it is 1.0.1. Currently it is building user service Docker image. Before building this Docker image, let me try to describe this pod case. Okay, let me cancel this. Let me copy this name and kubectl describe pod, and let me provide the pod name. Copy this pod name and paste it here. And I'm going to show you all the 7 Docker containers, guys. Okay, and here you can see successfully assigned to the default namespace. So this is the pod, it is scheduled. Now this is the Jenkins inbound agent pod, which is comes with latest, and this is the Canico, and this is the Node.js, and this is the Golang, and this is the Docker, and this is the Helm, and this is the G Cloud, guys. Okay, totally this pod is carrying 7 Docker containers. Okay, now let me run this command kubectl get pods hyphen watch, and after completing this job, right? Let me open this. After completing this job, it is going to destroy this pod, guys. Okay, I will show you that in live. Before that, let me come here. So user service is completed. Let me come here and let me go up, and user service build is completed and it has tagged with 1.0.1 and successfully it has pushed it, guys. Okay, so here you can see docker push, and also it has removed from this container, guys. Okay, so now let's come down and let's check in the GCP artifact registry. Let me refresh this. Okay, so here we need to see one docker image for user service. Okay, so user service, if you open this, inside this you can find a user service docker image, guys. Okay, so here you can see with 1.0.1 tag. Okay, so this is how it is going to push everything. Now let me open Jenkins pipeline, and here you can see search service is also completed. Currently it is building for booking service. Let me open this and let me go up, and here you can see search service has been pushed successfully with latest tag and with 1.0.1, and it has removed successfully from the container. Now it has entered into booking service and currently it is building booking service docker image, guys. Okay, let me open artifact registry. Let me refresh this, and here you can see search service. So if I open this search service, inside this you can find docker image which is 1.0.1. Okay, now let me go back and let me open Jenkins, and here you can see right now it is building booking service docker image. Let me go up, and here you can see booking service, and booking service is also completed. Right now it is building for payment service, and here you can see it is building payment service docker image. Let me open GCP Artifact Registry and let me refresh this. And here you can see booking service. Inside this you can find booking service Docker image. So here you can see booking service Docker image. Now let me open this. It is currently building for payment service guys now. Okay. So here you can see payment service Docker image has been pushed successfully. Okay. So this is the payment service one. After payment service, it has redirected to notification service. Currently, it is building Docker image for the notification service. Meanwhile, let me open Artifact Registry and let me refresh this. And here you can see payment service. Inside this payment service, you can find Docker image for the payment service case. Okay, here you can see 1.0.1. So this is the payment service Docker image. Let me go back and let me open this pipeline. And now it is going to build this notification service. Let me come here. So here you can see we are inside the notification service. Currently it is building the notification service Docker image. And it has completed successfully, I believe. Okay, so it's completed successfully. And it has pushed this Docker image to GCP Artifact Registry notification. Now let me open this Artifact Registry. Let me refresh this. Here we need to see notification folder. So here you can see notification service. And inside this we can find notification service Docker image. So here you can see it's tagged with 1.0.1 guys. Okay. Now let me open this. Currently it has redirected to front end and now it is currently building front end Docker image guys. Okay. So let me come here. So here you can see it is building the front end Docker image right now. So from second builds, it will not take this much of time guys. Okay. It will build very fast using 𝐤𝐻, existing 𝐤𝐻. Let me come here. So let's wait for some time to build this front end Docker image. So here you can see it has successfully pushed this front end Docker image to GCP Artifact Registry. Let me come here and let me refresh this page. And here you can see front end. And inside this you can find front end Docker image guys. Okay, so this is the front end Docker image. Let me quickly open this Jenkins pipeline and let me come down. And here you can see right now it is currently installing Trivy and it is going to scan all the Docker images. Let me come down. So here you can see it has installed Trivy and this is the Trivy version inside this Docker container. And now it is scanning all the Docker images like user service and it is going to display high and severe critical vulnerabilities. And next after this, let me come down. So the next service is search service and it is going to display high and critical vulnerabilities and you can see in detail report here. So now the next service is booking service and this is the high and critical vulnerabilities for booking service. Okay, so let me come down and next it is going to check for payment service for high and critical vulnerabilities. So this is the entire report. Let me come down and this is the notification service report guys. Okay, for high and critical vulnerabilities. Okay, Privy is going to scan everything guys. Okay, next here you can see, let me come here. So here you can see it has updated Helm values.yml file and here you can see it is updated with 1.0.1 for all the services like for front end user service, search service, booking service, payment service, notification service, and it is updated on Helm values.yml file. And here you can see it has grabbed this values.yml file. So it has successfully updated with front end 1.0.1 and user service, search service, booking service, payment service, and notification service with this same tag. And next, let me come down. It has packaged this Helm chart successfully with this tag with 1.0.1.tgz. And next, it is going to connect to our Google Cloud account using GCP service account JSON. And it is going to set this project and it is going to log into our Helm repository and it is going to push this Helm chart to our GCP Artifact Registry, guys. Okay. Finally, it is going to connect to our Google Cloud account using service account JSON file. And next it is going to install this gcloud auth plugins. Next it is going to install Helm, and here you can see it has successfully checked the nodes. So these are the two nodes, and here you can see it has pulled the Helm repository, and right now it is installing the Helm repository, guys. Okay, so here you can see release travel booking does not exist. Installing it now. Currently, inside our GKE cluster, right now it is installing this Helm chart, guys. Okay, meaning it is right now it is currently deploying this Helm chart. If you want to check this, you can directly come here. Let me open another tab and Helm ls-a. Here we need to see travel booking, guys. Okay, it is not showing kubectl get ns, and here you can see travel booking namespace. It's created last 2 minutes 9 seconds ago. Let me describe this, or else let me do kubectl get pods -n travel booking. Okay, so most of the images are going to image pullback off. Let me describe one pod, or else let me open this. Okay, so that is the reason why it is not coming to running. So 5 minutes. After 5 minutes, it is going to fail, guys. Before that, let me try to debug the issue. Let's try to describe any single pod, guys. That will be enough. kubectl describe pod, and you can directly provide the pod name and namespace name -n travel booking. Okay. Now let me check the issue successfully assigned to the default namespace and back off pulling image. Okay. So error image pull back off. So currently it is trying to pull this Docker image, but it was unable to pull this Docker image, guys, because we haven't provided our service account JSON file for these deployment files. So for now, let's try to provide public access for this repository, guys. Okay. Then it can able to pull those images. You can directly select this show info panel, and here directly select add principal and all users. Okay, and directly select here basic and owner permissions and save. Okay, and allow public access. So now we have provided public access for this artifact repository, and still it is updating. Right now let me open this, and let me clear the screen. kubectl get pods -n travel booking -watch. Now let's see whether this will come to running state or not. Most probably it will come to running state, guys. Okay, because we just provided public access for that repository. So if you want to pull a private repository images, you need to create a Kubernetes secret using your GCP IAM service account JSON file, and you need to update that secret inside this deployment, guys. Okay, in that case you can directly pull your private Docker images to your GKE cluster, guys. Okay, so let me open this pipeline, and let's wait for some time. Let me open this pipeline, and let me open this. So here you can see, as I said, this stage got failed, guys. Okay, so failure, no problem. So after completing this builds, so it has run Docker image prune, and it has saved nearly 2.915 GB, guys. Okay, so this is how it is going to work. So now let me retrigger this pipeline, guys. Okay, build now, and let me refresh this, and here let me open this tab, guys. Okay, so here you can see after completing this build, it has terminated that pod, and right now it is creating new pod, guys. Okay, it's in error. Let me cancel this. kubectl get pods -watch, and here you can see right now it's in the creating state, container creating state. So for this second build, it is going to create the pod. Okay, waiting for next availability executor on this pod. So currently it's in the container creating state. So let's wait for some time. So here you can see this pod has started, meaning this pod came to running state. So here you can see after 105 seconds, this pod came to running state, and this pipeline has started. Everything is okay. Right now it is doing go testing for all the 5 go backend services. So I will skip this everything, guys. Okay, so let's wait for deploy to GKE stage, and let's see whether it will deploy or not. Meanwhile, let me open this tab, and okay, so all the pods are in running state, guys. Okay, I think it was pulled successfully. kubectl get pods hyphen and travel booking. So here you can see all the pods are in running state, guys. Okay, but anyhow this pipeline was failed. So let's wait for some time till this pipeline is green. Before that, if you want to check everything like all the deployments, services, config map, secrets, let's check that, guys. Okay, so let me clear the screen. Before that, helm ls hyphen a, it is going to show the helm chart. So here you can see this is the travel booking helm chart. For the very first time it was failed, guys. Okay, now in the second run it will be deployed, guys. Okay, I will show you that. Meanwhile, let me come here. Now let me run this command kubectl get all hyphen n travel booking, because we install this helm chart on the travel booking namespace. So let me hit enter. So now it is going to show you all the pods, deployment services, replica sets, stateful sets, HPS and everything. So let me come up. So here you can see this is the booking service pod and this is the front end service pod. This is the notification service pod and this is the payment service pod and this is the PostgreSQL pod and this is the Redis pod and this is the search service pod and this is the user service pod, guys. Okay, all the pods are in running state and these are all the services. So this is the booking service, front end service, notification service, payment service, Postgres, Redis, search service, user service, guys. Okay, and these are all the deployments and these are all the replica set and this is the stateful set. Okay, so we created this PostgreSQL database as a stateful set and this is the horizontal pod autoscaler for all the microservices, like for booking service, front end service autoscaler, notification service autoscaler, payment service autoscaler, search service autoscaler, user service autoscaler, guys. Okay, and a part of this mainly we are going to create a gateway. So let me come here, gateway hyphen n travel hyphen booking. Okay, so for this gateway we are going to associate this IP address. Okay, so we created this static IP address using Terraform. If you want to confirm this, you can directly open VPC. Let me open VPC network and IP addresses, and here you can see this is the travel booking IP. It's created using Terraform 34.54.11.71. Let me come here, 34.54.11.71. Okay, so it is using that same IP address. So let me open this and let me open Helm and templates gateway.ml, and here you can see a static IP name, right? So let me come here and values.ml and let me come down and gateway. So here you can see travel booking gateway name. Okay, so this is the static IP name, travel booking IP. So if I open this, here you can see travel booking IP. So same IP address we are associated with this gateway. So that is the reason why this gateway has used this IP address. So now we need to associate this IP address with GoDaddy domain provider, guys. Okay, before updating, let me do kubectl get http routes hyphen n travel booking. So these are all the HTTP routes for the travel booking application. Now let me run this command kubectl get secrets hyphen n travel booking. So these are all the secrets for our travel booking namespace. So booking service secret, notification service secret, payment service secret, poster secret, and search service secret and user service secret, guys. Okay, apart of this we are also creating config maps. Let me do kubectl get config map hyphen and travel booking. So here you can see these are all the config maps, and we are also creating HPA horizontal pod autoscaler for all the services. So here you can see these are all the horizontal pod autoscalers for all the microservices. And apart of this, we are also creating a stateful set STS, and here you can see PostgreSQL stateful set, guys. Okay, so all these were created using this Helm chart, guys. Okay, so with single command we can directly install all these resources. Okay, we integrated directly this Helm chart with Jenkins pipeline, guys. Okay, so that is the one of the beauty. So in real time we will follow this same approach, guys. Okay, so now let me open this tab, and still this job is running. Let me open this, and currently it's building the payment service, guys. Okay, and let me come here And let me do one thing, kubectl, clear the screen, kubectl get pods -n travel. Okay, let me give some spaces, travel-booking. Before upgrading this Helm chart, let me show you the tag name. Let me copy any of the pod name. Now let me describe this pod, kubectl describe pod, and let me provide the pod name, and namespace name is travel-booking. And let me show you the image tag, right? So this is the image tag which is 1.0.1. So once this pipeline is green, right, it will deploy with latest image which is 1.0.2, because the current Jenkins build number is 1.0.2, right? Right now it will build all these Docker images and it will tag these Docker images with 1.0.2, and it will push this Docker image to GCP Artifact Registry. Next, it is going to update those images on Helm values.ml file, and it is going to package this Helm chart, and it is going to put that Helm chart to GCP Artifact Registry. And in the final stage, it is going to deploy latest Docker images like 1.0.2 images to this GKE cluster, guys. Okay, right now it's 1.0.1, right? So after this deployment, I will show you the new Docker images which is 1.0.2. Meanwhile, let me do kubectl get pods -and travel booking and -watch. So while upgrading this Helm chart, this all pods will be recreated, guys. Okay, Helm will be upgraded with the latest images. So let's wait for some time. Let me open this. Okay. So now here you can see currently it's in the deploy to GKE stage. Let me come here, and here you can see Helm upgrade. I think it's completed, guys. Okay. So here you can see all the pods were recreated with new tags. Let me open this. Right now it is doing Docker system prune, and it has cleared nearly 2.915 GB, and the pipeline is green now. Okay. So now let me close this. So here you can see now pipeline is green. So now let me cancel this and let me show you Jenkins pod. Okay. So here you can see after completing this job, this pod was terminated, guys. Okay. So this is the main advantage of running Jenkins inside your Kubernetes cluster itself, guys. Okay. Let me come here and let me cancel this, and let me run this command kubectl get pods -and travel booking. And here you can see last 70 seconds ago, apart of Postgres and Redis, all the services pods were created, guys. Okay. So now let's try to describe any single pod. Let me copy this pod name and kubectl describe pod name -n and travel-booking. And now here you can see we need to see tag as 1.0.2. So here you can see 1.0.2 tag. Okay. So this is how always this Jenkins pipeline is going to deploy Helm chart with latest Docker images, guys. Okay. So now let me show you the Helm chart, Helm ls-e. Earlier it has showed failed, right? So now here we need to see deployed and travel booking, and currently it's deployed, guys. Okay. Status, it's deployed, and all the pods are in running state, guys. Okay. So now let's try to access this application. Let me run this command kubectl get gateway -n travel-booking. So now using this gateway IP address, we need to access our front-end UI, guys. Okay. So basically this is our load balancer IP address. Behind the hood, it is going to create a load balancer, guys. Okay. When we create this gateway, so this gateway will create a load balancer, guys. Okay. So this gateway is created by Helm chart itself. We are not going to do even a single manual effort, guys. Okay. Let me select here load balancing, and this is the load balancer, guys, application load balancer. So for this load balancer, we have associated this IP address. So now let me copy this and let me open incognito window, open new tab, http:// and IP address, and hit enter. Now continue to site. It is going to display our travel booking application, guys. Okay. So here you can see we can successfully able to access our travel booking application. So now initially we need to create an account. So previously I explained everything, right? So before creating this accounts, let's try to access PostgreSQL database. So you can directly open this docs and PostgreSQL database guide.md. And initially, let's try to check all the databases are available or not. Let me copy this command. I'm going to connect to this Postgres-0 Postgres. Okay. So basically this command is going to open Postgres SQL shell. So here you can see it's open and /l. And here you can see bookings DB, notification DB, payments DB, search DB, and user DB. Everything is created successfully, right? So now let me exit from this. And now let's check all the registers users. See all the registered users, guys. Okay. So right now we haven't registered even a single user, right? So now let me run this command. Here we need to see 0 rows. Okay, 0 rows. We haven't registered even a single user. So now let's try to register a user, guys. Okay, let me open this tab and directly select here create free account. So name I am going to provide Vijay and email vijay@gmail.com, and the password is vijay@123, and confirm password vijay@123, and create free account. Okay, so now in travel booking application account is created successfully. So earlier it has shown 0 rows, right? So now let me run this command. Here we need to see 1 row, and here you can see user Vijay is created, vijay@gmail.com, role is traveler. So now let me sign out from this. Now I'm going to create second account. Before creating second account, using existing email, if you want to log in, you can directly select here, provide your email address and password, guys. Okay, so I'm going to provide this email address and password. So email address as vijay@gmail.com, and password is vijay@123, and sign in. Okay, so now automatically it will connect to this travel booking platform, because already these login credentials are available inside this database, guys. Okay, using these credentials, automatically it will log into our travel booking platform. So now let me select just sign out. I'm going to create another account. So that account name is Naresh, and naresh@gmail.com, and password is naresh@123, and similarly naresh@123, and create free account. Okay, so here you can see Naresh account has been created successfully in travel booking platform. Now let me check this second application, and here you can see it's created, guys. Okay, naresh@gmail.com. Similarly, if you want to create another account, you can directly select create free account. So the account name is Shravani, and email address shravani@gmail.com, and password shravani@123, and confirm password shravani@123, and create free account. Okay, so here you can see Shravani account has been created successfully. So this is how you can create multiple accounts inside this travel booking platform, guys. Okay, so this application will work similarly like a real-time application. Now let me query this command. And here you can see Shravani@gmail.com. Total 3 users has registered in this travel booking platform, guys. Okay, so now if you want to log into other account like naresh@gmail.com, and password is naresh@123, and sign in, it will connect to Naresh account, guys. Okay, so this is how it is going to show each and everything. Now let me open this, and if you want to count total users using this query, you can count all the total users. Okay, let me clear the screen. Let me copy this once again. Copy, paste, and here we need to see total 3 users. So here you can see total users is 3. So now if you want to find a specific user by email, you can directly run this. And if you want to see users registered today, you can directly run this command, guys. Okay, so just now we registered these users, right? It will display all the 3 users. Let me copy this once again. Copy and paste. Okay, and here you can see we registered all these 3 users just now, so that is the reason why it is showing. Okay, so now let me try to test this UI. Let me open this. So using Naresh user, I'm going to book flight, so from New York to San Francisco on 21st. Search flights, and if you want to sort this, you can directly sort this from low to high, or high to low, or shortest or longest. You can directly select anything. Let me select high to low, Let me select this first flight, book now. Now, previously that search is handled by the search service. Now these bookings will be handled by the booking service guys. Okay, so let me provide name like Vijay and Vijay Gidu. Okay, email vijay@gmail.com and phone number 1234567890. Okay, now if I select here confirm and pay, this will be handled by the payment service case now. Okay, so you need to provide any dummy card number. Okay, so this is the number I'm going to provide. So card holder name is Vijay 0928 and CVV. So here you can see while I was typing the CVV right here, it is not showing. Let me provide the 344. Okay, so you can provide any of the name. So if I select this pay, this will be handled by the payment service case. Okay, so payment got filed. Please check your card details and try again. Okay. Hmm. Let me remove this one, 1 2 3 4 5 6 7 8 9 0 and 1 2 3 4 5 6. Okay, pay now, and this will be handled by the payment service. So now here you can see payment confirmed. Okay, so this is how all these microservices will work together guys. Okay, in my trips page you can find your upcoming flight. So this is your upcoming flight. If you want to cancel this, you can directly cancel this. So now if you want to book hotel, you can directly select your hotel and you can directly search city. I'm going to select Los Angeles and the check-in is 16th and check-out is 17th and the number of guests are 2 such hotels, and these are the hotels available. I'm going to book this hotel. So the name is Vijay, and let me remove this number 1 2 3 4 5 6 7 8 9 0, and let me remove the 67 and let me select. So this page will be handled by the booking service case. Okay, so now if I select here confirm and pay, this will be handled by the payment service. Again here you need to provide your card details. I'm going to provide some dummy card details 44. Okay, okay, now let me provide name like Vijay, expiry 0920, K38 CVV 344 Now this will be handled by the payment service case. Okay, now payment confirmed. Okay, so in my trips page you can see we have booked one flight and one hotel from Naresh user guys. Okay, so if you want to check this, you can directly open this and search. Okay, so let's leave this. I already explained about all these commands. Now let's come to bookings TB and see all bookings. Okay, let me copy this command and let me run here. Okay, it's not copied properly. Let me copy this command once again. See all bookings. It is going to show you all the bookings guys. Okay, so we have booked one hotel and one flight. So here you can see one hotel and one flight. Okay, so this is how it is going to show us across all the users guys. Okay, so now for payments, if you want to see all the payments, you can directly run this query, copy this, paste it here. Let me copy this properly, copy, paste. Okay, and here you can see this is the payment summary. So one we got 341 USD, one we got flight for 1235 USD guys. Okay, so currency it's in the USD. So this application will work similarly like a real-time application guys. Okay, so right now we haven't received any notifications, so it will not show us any notifications guys, I believe. Okay, let me run this command. uh, okay, so we have notifications like, okay, payment success notification, booking confirm notification, payment success notification. Okay, so this comes under notifications guys. Okay, so we tested this application right. So now let's jump on to DNS guide. Where is this gateway API DNS guide? Okay, so now currently we are accessing our applications using a gateway API DNS, sorry, gateway API load balancer, right? So now let's try to access our application using our GoDaddy domain guys. Okay, for that we need to follow this documentation. Let me come down. So already we created this gateway using Helm chat. Okay, so it's not necessary to create this. Now what we need to do is we need to run this command kubectl get gateways hyphen and travel booking, and we need to update this IP on GoDaddy, guys. Okay, so let's come down, and here you can see you need to update DNS on GoDaddy. So you need to create a record. Okay, so let's update this now. Let me open this, clear the screen, kubectl get gateway hyphen n travel booking. So now we need to update this IP address in GoDaddy. Let me open GoDaddy. Okay, so this is my GoDaddy account. So this is the A record. Okay, let me edit this. So this is the old IP address. Let me copy this 34.54.11.71, 34.54.11.71. Okay, so now I'm going to save this. So we need to wait for at least 5 to 10 minutes. Sometimes we need to wait for more than 1 hour to update this DNS. You can directly check this DNS by running this command ns lookup vijay.in. So in this case, you need to provide your domain name, guys. Okay. So here you can see it is showing our old IP address. We need to see this new IP address, guys. So because this is our gateway IP address. So once after completing this, let me open this. Once after completing this, we need to update this gateway with this host name, guys. Okay. So uh, let's update this everything without wasting any time. So let's update this gateway inside Helm chat. Let me okay. Let me open GitHub repository in another folder, guys. Okay, repositories and travel booking, and here you need to open this Helm. Where is this Helm and travel booking? And you need to open these templates, and here open this gateway ML, guys. Okay, so you can directly update this ML and you can directly run this pipeline, or else you can directly copy this and you can directly run this inside this terminal, guys. That is also not a problem. Okay, but I'm going to update this inside this Helm chat itself, and I'm going to run this pipeline. Let me edit this. I'm going to remove this. Okay, so we are just updating this host name with vijay.in, guys. Okay, because anyhow we just updated this gateway IP on our DNS name, right? So let me open this DNS. Okay, so here you can see we updated this on GoDaddy with my domain vijay.in, right? So I just updated this domain name on this gateway, guys. Okay, so host name is vijay.in. So now I'm going to commit these changes and commit changes. Next, let me open this. So after updating this, we need to update all the HTTP routes with domain names. Okay. So this is the front end HTTP route. So let me open this and let me run this command kubectl get HTTP routes hyphen n travel booking. And here you can see right now we don't have host names, right? So we are going to update this host names, guys. Okay. So for all the services, for front-end service, we are going to update this hostname vijay.in, and for users HTTP route, we are going to update this hostname vijay.in, and for search service HTTP route, we are going to update this hostname. Similarly, for booking HTTP route, we are going to update this hostname. For payment HTTP route, we are going to update this hostname, and for notification HTTP route, we are going to update this hostname base. Okay. So instead of directly applying in this terminal, I will update this inside the GitHub repository and I will run the pipeline, guys. Okay, so that pipeline will update everything. Let me copy this and let me open this GitHub and http routes.ml, and let me edit this. Let me remove all this and let me paste it here, guys. Okay, so let me check this once again. We are going to update this hostname for all the HTTP routes. Okay, because earlier we don't have HTTP routes, right? So now let me select here commit changes and commit changes. Okay. So in single go, it is going to update this HTTP routes and also gateway, guys. Okay. So let me come here. And next, we need to create this health check policy for Jenkins. I will explain you this later, guys. Okay. Meanwhile, let me run this pipeline. Let me trigger this pipeline. Okay. I just triggered this pipeline. So it started building console output. And now here you can see it's created pod immediately, guys. Okay. As I said, from second or third builds, it will start immediately. And here you can see within 6 seconds, it has started running this pipeline. kubectl get pods hyphen watch. And here you can see it's running. So now let's wait for some time. Let me open this and let me come down. And currently it is doing Go testing for all the 5 backend services. So meanwhile, let me come here. Similarly, let me show you for gateway kubectl describe gateway. So the name of the gateway is travel booking gateway. Copy and paste and hyphen n travel hyphen booking and grep host name. Okay. So basically it is going to show the host name. Right now we don't have any host name for this gateway even, guys. Okay. For gateway and for all the HTTP routes, we don't have host name. So after this pipeline is green, right, it will update gateway as well as it will update all the HTTP routes with the host names, guys. Okay. So from now, let's wait for some time. So before that, let me explain you about this Jenkins gateway access case, like about this Jenkins health check policy. So here you can see I have written everything in a clear cut way. Jenkins runs in the default namespace, but not in the travel booking namespace. We need to create a HTTP route and then health check policy so the gateway can route at slash Jenkins traffic to Jenkins service case. Okay. So now why do we need to create this health check policy? So by default, GCP load balancer health check policy serves at slash endpoint on the backend service. But the Jenkins is configured with URL prefix with slash Jenkins, guys. Okay. So if I come here and if I tag this Jenkins custom values.ml, okay, it is serving a Jenkins URI prefix at slash Jenkins, right? So it's health check endpoint details slash Jenkins and slash login, but not at slash case. Okay. So without this health check policy, GCP will mark Jenkins as unhealthy and it will return no healthy upstream, guys. Okay. So that is the reason why we are going to create this health check policy. Okay. So let's try to create this health check policy directly here itself without wasting any time. Okay. So we are created this health check policy. Now kubectl get health check policy hyphen n. Okay, so we are creating this health check policy on the default namespace for Jenkins, and let me hit enter. And here you can see last 17 seconds ago it's created. And if you see target reference kind is service and it is pointing to Jenkins service case. Okay, so let me do kubectl get service grep Jenkins, and here you can see it is pointing to this Jenkins service case. Okay, so this health check policy is pointing to this Jenkins service. Now let me open this. Next we are going to create this HTTP route. So this HTTP route will route traffic at slash Jenkins case, okay, with this host name. So whenever any user is trying to access with vijay.in slash Jenkins, so this HTTP route will route traffic to this backend service Jenkins on port 8080. So here you can see Jenkins on port 8080. So now let me create this health check policy. So we are creating this, sorry. So this is HTTP route. So we are creating this HTTP route on the default namespace kubectl get HTTP route. And here you can see Jenkins HTTP route. We have provided host name as vijay.in. Okay. So now let's come down and verify Jenkins routes. So we verified everything. We verified HTTP route as well as health check policy. And after completing this, we need to test this with domain name with vijay-3.in. So let's wait for some time, guys. Okay, let me open this. Okay, so the pipeline is also green, guys. Okay, so now let me do kubectl get pods, or else I think. Okay, so this pod is terminated successfully. Kubectl get pods -n travel booking pods will be recreated, guys. Okay, so here you can see it's created last 77 seconds ago. So now currently Jenkins build number is 3, right? So now here inside this we need to see tag as 1.0.3. Let me check for any single pod. kubectl describe pod, and let me provide the pod name -n travel booking, and here we need to check 1.0.3. Okay, so the tag is 1.0.3. It has deployed the latest pods. Okay, so now mainly we need to check gateway, guys. kubectl get gateway -n travel booking. So here you can see gateway is updated, I guess. Let me describe this. kubectl describe gateway, and name of the gateway is travel booking gateway -n travel booking, and let me grep for host name grep host. Okay, we need to see the host name as vijay-3, guys. Okay, so here you can see it's updated successfully with host name vijay-3.in. Now let me check all the http routes. kubectl get http routes -n travel booking. So here we need to see host names vijay-3.in. Okay, so this is how this pipeline is going to update everything, guys. Okay, so now we need to check this IP address for our domain. Let me run this command ns lookup vijay-3.in, and here you can see it's updated successfully 34.54.29.31 34.54.29.31. Okay, so now let me try to test this. Let's try to test this Jenkins via our domain. So we need to see expected code as 200. Let me copy this. Let me paste it here. Okay, let me copy this once again. Copy and paste. And status code is 200, guys. Okay, meaning it is working fine. And verify everything. Okay, so these are all not necessary. If you want to test front end, you can directly call this, and we need to see expected code as 200, guys. Okay, let me copy this once again, paste it here, and here you can see expected code is 200. So we can able to access UI with this domain vijay-3.in. Now if you want to test API, you can directly test this. If you want to test Jenkins, you can directly test this. So I think already we tested Jenkins, right? So here you can see Jenkins we already tested, and it has expected code is 200. So everything is completed for domain mapping. So now let's try to access our application with DNS. Let me open another tab, and http://vijay-3.in. It needs to redirect to our application, guys. Okay, and here you can see we can able to access our application with our domain vijay-3.in. So similarly we need to access Jenkins with our domain, guys. Okay, let me open another tab, http://vijay-3.in/Jenkins, and here you can see we can able to access Jenkins also, guys. Okay, let me provide username as Vijay and password as Vijay@123 and sign in, and we need to see all the pipelines, and here you can see travel booking pipeline, and inside this you can see all the 3 builds, guys. Okay, so this is how you can able to access this Jenkins and your application using this domain access, guys. Okay, because we directly install Jenkins inside our GKE cluster, guys. Okay, so now I'm going to close this everything. So now let's set up monitoring stack for our travel booking application. So you can find this monitoring stack inside monitoring directory. So let me open this VS Code and let me close this Helm. And inside this monitoring directory, you can find all the YAMLs for monitoring stack, guys. Okay. So you can directly follow this monitoring.md file and you can directly set up monitoring inside your Kubernetes cluster. Okay. So let me give you some small overview. So this monitoring stack uses Prometheus, Grafana, and Alert Manager to track everything happening inside our application. Without monitoring, we have no idea if services are slow, crashing, or running out of memory until users complain. So now let's start this implementation. You can follow this monitoring.md file to set up monitoring stack on GKE cluster, guys. Okay. So let me open this on GitHub, and this is the monitoring. And here let me open this monitoring.md file, guys. Okay. And let's come down. So let's directly jump on to step 1. So this is the step 1 is okay. First we need to add this Prometheus community Helm repository, which contains the Cube Prometheus stack chart. And this single chart installs everything like Prometheus, Grafana, Alert Manager, Node Exporter, and Cube State Metrics case, okay, all in one go. So now let me apply this in my GKE cluster. Before that, let me check for the repositories, Helm repo and ls. It is going to show all the Helm repositories. Part of Jenkins, we don't have even single Helm repository, guys. Okay. So now I'm going to add this Helm repository. It is going to add and parallelly it will update this repository, guys. Okay. And here you can see update is also complete. So now let me run this command Helm repo ls. So here you can see Prometheus community. So now let me open this file. So in second step, we are going to create a separate namespace called monitoring to keep all monitoring resources isolation from the application pods case. Okay. So now let me copy this and let me show you all the namespaces first inside our GKE cluster. So here you can see we don't have a monitoring namespace. So now I'm going to create a namespace monitoring. Let me copy this entire command and paste it here. And here you can see monitoring namespace has been created successfully. So now kubectl dataNS and grep monitoring, and here you can see monitoring namespace has been created last 11 seconds ago. So now let me open this. Now in the step 3 we are going to install Cube Prometheus stack. So this is the main command, guys. It installs the chart with our custom values file and hyphen set flags to 3 things, like it reduces resource request. So Prometheus doesn't get stuck in pending state on smaller clusters, and it disable persistent storage to avoid PVC scheduling issues and configure subpath access. So Grafana serves at /Grafana. Prometheus can serve at /Prometheus and alert manager at /alert manager instead of root path case. Okay. And this subpath setup is needed because all three share the same gateway load balancer with the main application, guys. Okay. So before that, we need to update these domain names. So let me copy this and let me open my notepad. Okay. And let me paste it here. So here we need to update our domain name, guys. Okay. So this is my domain name, kubectl get gateway -n travel booking. So this is the gateway IP we associated with our GoDaddy DNS, right? So now let me run this command ns lookup vijay-gidituri.in. So okay, it is showing some different IP. Let me try to access this application. Okay. So we need to update this domain name here, guys. Okay. So let's update this here vijay-gidituri.in. So here you need to update your domain names, guys. Okay. So whenever we are trying to access with http://vijay-gidituri.in/grafana, it will redirect this traffic to Grafana service. Similarly, if we hit /Prometheus, it will redirect to Prometheus. Similarly, if we hit /alert manager, it will redirect to alert manager, guys. Okay. So now let me change this to vijay-gidituri.in. And similarly here, let me change this domain name for Prometheus vijay-gidituri.in. Okay. So now I'm going to apply this. Let me copy this and let me paste it here. Okay, let me copy this once again and let me paste it here, guys. Okay, so from now it will take around 1 or 2 minutes to install this 𝐶 stack. So let's wait for some time. So here you can see this Helm chart has been installed successfully. So now let's check this. Before that, let me open this documentation. So step 3 is installed successfully. Now in step 4, we need to verify all the pods, services and PVCs for this monitoring namespace. So let me open this and Helm ls-a. It is going to show us all the Helm charts. So here you can see 𝐶 stack Helm chart has been installed on the monitoring namespace. So now let me see all the pods, kubectl, get pods -n monitoring. And here you can see all the pods are in running state, guys. Okay. Similarly, let me check for services, kubectl get services -n monitoring. Okay. So similarly, let me check for PVC. Okay. So right now we don't have any PVC, guys. Okay. And now let me run this command kubectl get services -n monitoring. So if you want to access alert manager, so you can directly access alert manager dashboard with your node IP with this node port. Similarly, if you want to access Grafana, you can directly access with your node IP with this node port. And if you want to access Prometheus, you can directly access node IP with this 30090 node port, guys. Okay. So I will show you that later. Now let me open this and let me come down. Now in step 5, we are going to create service monitors. So basically service monitors are Kubernetes resources that tell Prometheus which service to scrap. So we are creating 5 service monitors, one for each Go backend service. Each monitor says scraps this service on port HTTP at path/metrics for every 15 seconds. Without this, Prometheus won't know our application service exists. Okay, now let me apply these AMLs. So before applying these AMLs, if you want to see this inside monitoring, you can directly open these service monitors. So this is the service monitors. You can find all the service monitors, guys. Okay, so this is the booking service monitor, notification service monitor, payment service monitor, search service monitor, user service monitor, guys. Okay, so let me show you here. Let me come out from this Jenkins directory and let me enter into this monitoring and cd service monitors and let me do ls, and here you can see these are all the 5 service monitors. Right now we are going to apply. Let me catch this. So this is the booking service service monitor ml. Similarly, if you want to see for payment service, this is the payment service ml, and if you want to see for user service, this is the user service ml. Next, similarly, if you want to see for notification service and search service, cat notification service, so this is the service monitor for the notification service. Similarly for search service, similarly for the search service, this is the service monitor, guys. Okay, so now let's try to apply all these service monitors. Let me come out. Okay, so now let me open GitHub and let me copy this command, guys. Okay, now let me open this and let me hit enter. Now it is going to create 5 service monitors, guys. Okay, so here you can see booking service, notification, payment, search and user. So now let's check these service monitors. So you can directly run this command kubectl get service monitors -n travel booking, and let me paste it here. Okay, let me copy once again, copy and paste. Okay, and here you can see all the service monitors has been created successfully. Now let's come down. Now we are going to create Prometheus alert rule resources that define when to fire alert. And here we have 6 rules like pod down fires when pod is down for 1 minute, and high CPU and high memory rule. So when usage exceeds 80% for 5 minutes, and high HTTP error rate fires when 5 errors exceeds 5%, and high response time fires when 95th percentile response time exceeds 2 seconds, and pod restart loop fires when pod restarts for more than 5 times in 15 minutes, guys. Okay, So now let me apply these alert rules. So if you want to see all these alert rules, again you can find alert rules inside this monitoring directory itself. And here you can see these are the alert rule. So let me show you this first. Let me open this tab and let me do ls cd monitoring and cd alert rules and ls and cat travel booking alert rule.ml. Okay, so these are all the alert rules we are going to create, guys. Okay, so now let me apply this ml. Let me copy this and let me paste it here. So now it is going to create alert rule. So now let's check this alert rule, Prometheus rules. Copy this and paste it here. And here you can see travel booking alerts. Last 9 seconds ago it's created, guys. Okay, so now let's apply Grafana dashboards. So now in step 7 we are going to apply Grafana dashboards. So this command creates config map resources containing Grafana dashboard JSONs. So Grafana has a sidecar container that watches for config maps with the labels Grafana dashboard and automatically loads them as a dashboards case. Okay, so it is going to create 6 dashboards, like an overview dashboard shows the entire application health, and one dashboard for service with detailed metrics like request rate, response time, and error rate case. Okay, so now let me apply all these amens. Before that, let me show you all these dashboards. So you can directly see these dashboards inside this monitoring directory itself. So here you can see, if you drop down this, we have multiple dashboards like booking service dashboard, notification service dashboard, overview dashboard, payment service dashboard, search service dashboard, and user service dashboard, guys. Okay, so now let me show you those mls. Let me come out from this and cd dashboards and ls. So here you can see these are all the dashboards, guys. Okay, so basically these are the config maps, guys. Okay, let me open any single service, which is booking service, and here you can see we are going to create a config map. Okay, so now let me apply all these dashboards. Let me copy this command and let me paste it here. And okay, let me copy this once again. And here you can see all the config maps are creating successfully. Booking service, it's created. Notification service dashboard created. Overview dashboard created. Payment service dashboard created. Search service dashboard created. User service dashboard is also created, guys. Okay, so now let's come down and let's check whether this is created or not. Let me copy this command and okay, let me copy this command properly and let me paste it here. And here you can see this is the notification service dashboard. So here you can see it's created last 30 seconds ago. Notification service dashboard, overview dashboard, payment service dashboard, search service dashboard, user service dashboard, and at top you can see booking service dashboard. It's created last 29 seconds ago, guys. Okay, so now let me open this terminal once again. Now we are going to create GCP firewall rules for node ports 30,000 to 32,767, guys. Okay, because we need to access these three, Prometheus, Grafana, and Alert Manager, through this node port side. So that is the reason why I'm going to provide access for all these node port range, guys. Okay, let me copy this and let me come here and let me paste it here. Let me hit enter. Okay, we need to replace the project ID. Let me paste it once again. And here you need to replace your project ID, guys. Okay, and directly remove this your project ID. And here copy your project ID. Drop down this, and here you can find your project ID. Copy this project ID and directly paste it here and hit enter. So now it is going to create a firewall rule error. Okay, could not fetch resources. Okay, it is telling already exits. That is good. So now let me clear this screen and let me open GitHub and let me come down. So now let's try to access Prometheus, Grafana, and Alert Manager. So you can directly run this command. So it is going to grep for only service type node port. So let me copy this and let me paste it here. And here you can see, so if you want to access Alert Manager, so using your node IP with this node port, you can directly access Alert Manager. So if you want to access Grafana, you can directly access with your node IP with this node port. And if you want to access Prometheus using this node IP and with this node port, you can directly access Prometheus case. Okay. So now let's try to access these three. So if you want specific node port, you can directly run this case. Okay. Just let me copy this first one and let me paste it here. And for Grafana, so this is the node port 32010. Let me run this command kubectl get nodes -o wide and copy any of the external IP. So I'm going to copy this external IP and I'm going to open incognito window and http:// node IP, and we need to provide our node port, guys. Okay, so now initially I'm going to access Grafana 32010. This is the node port, and let me hit enter. And you need to select here continue to site. Now it is going to open Grafana, guys. Okay. Meanwhile, similarly, let's check for Prometheus and also alert manager. So if you want to check for Prometheus, directly copy this command and directly run this command. Next, let's parallelly check for alert manager. Let me copy this, paste it here. And this is the alert manager node port and this is the Prometheus node port, guys. Okay. So now let me open this. Okay, let me do one thing 32010. Let me copy this and let me open TravelBooking VPC and firewalls. Okay, so this is the firewall. Create VPC firewall, Grafana firewall. Okay, so let's provide name something like this and targets all instances in the network 0.0.0.0/0 and TCP, and I'm going to provide this port, guys. Okay, which is 32010, and I'm going to select here create. So basically we are going to provide access for this node port for Grafana. Now let's try to reload this. Okay, it is redirecting to Grafana, guys. Okay, because we just directly provided these paths right in the step 1 while installing this chart. Let me come down. So here you can see we directly provided these paths right, like /Grafana /Prometheus and /alert manager. So that is the reason why it is directly redirecting, guys. Okay, so let's do one thing. Let me open this and let me come down. Okay, so let's skip this everything and let's come down. So these are all the Prometheus queries. I will show you this later. So now let's come down. Now let's try to access via our domain, guys. Okay, so let me copy this and let me open this terminal and let me paste it here. And here I'm going to modify these to 𝐕𝐺𝐺𝐺𝐷𝐻𝐻𝐼.in. And similarly for Prometheus also I'm going to modify to 𝐕𝐺𝐺𝐺𝐷𝐻𝐻𝐼.in. So this is my domain name. And for Grafana also I'm going to modify my domain name to 𝐕𝐺𝐺𝐺𝐷𝐻𝐻𝐼.in. So I can access these three Prometheus, Grafana and Alert Manager with my domain name, guys. Okay, 𝐕𝐺𝐺𝐺𝐷𝐻𝐻𝐼.in and hit enter. So now it is going to upgrade this Helm chart. So let's wait for some time. And here you can see it's upgraded successfully. And here you can see right now revision is 2. So now let me open this and let me come down. Now we need to create this health check policy because GCP load balancer need to know how to health check these services. So now we are going to create three health check policies. One is for Grafana and one is for Prometheus and one is for Alert Manager, guys. Okay. Let me copy these three YAMLs and let me open this tab and let me paste it here directly. Okay. Let me copy this and let me paste it here. And here you can see Grafana health check policy is created, Prometheus health check policy is created, alert manager health check policy is created, guys. Okay, so now if you want to verify this, you can directly verify this kubectl get health check policy -n monitoring, and here you can see all the three health check policies, guys. Here you can see it's created all the three health check policies. So now I'm going to create HTTP routes for these three services, because this HTTP route will route traffic when we hit vjgit3.in/grafana. Behind the hood, it will route traffic to this Grafana service, and this HTTP route will route traffic to Prometheus service, and this HTTP route will route traffic to the alert manager service, guys. Okay, so here you can see backend reference Q Prometheus stack alert manager, and for Prometheus Q Prometheus stack Prometheus, and for Grafana Q Prometheus stack Grafana, guys. Okay, so now let me copy this and let me paste it here, and these three HTTP routes I'm going to create on the monitoring namespace, case. Okay, so similarly health check policies also we are created on the monitoring namespace. So now let me check these three HTTP routes kubectl get HTTP routes -n monitoring, and here you can see it's created successfully with our host names vjgit3.in. So now let's come down. Now we can directly access this. So we need to wait at least 2 to 5 minutes for GCP load balancer to reprogram, guys. Okay, so let me do one thing. Let me open this web and let me open new tab http://vjgit3.in/grafana. Okay, so here you can see it is redirecting to travel booking platform, and it is showing 404 page not found. Okay, we need to wait at least 2 to 5 minutes, guys. Okay, in order to access this Prometheus, Grafana, and alert manager. Okay, so let's wait for some time. Now let's try to access Prometheus, Grafana, and alert manager on web. So let me open this and http://vjgit3.in/grafana, and here you can see we can successfully able to access with our domain name and /grafana, guys. Okay, so now let me connect to this Grafana. So Grafana username is admin and password is travelbooking@admin123, guys. Okay, so let me copy this. So the username is admin and this is the password, and let me select here login, and here you can see it's successfully connected to Grafana. Now let me try to access Prometheus http://vjgit3.in/prometheus, and here we need to see Prometheus page, and here you can see we can able to access Prometheus. Unable to fetch list names, invalid JSON. Okay, so let me refresh this page. Okay, we don't have that error now. Now let me try to access alert manager vjgit3.in/alert manager. Now here you can see with our domain/alert manager we can able to access alert manager dashboard. Similarly with my domain name .in/prometheus I can able to access Prometheus dashboard, and with my domain name /grafana I can able to access Grafana dashboard, guys. Okay, so this is how we can able to access with our domain names. So now let's try to see all our dashboards. So previously we created some dashboards, right, custom dashboards. So now I'm going to show you those dashboards. So you need to directly select here dashboards, and here you can see this is the booking service dashboard, guys. Okay, and here you can see it's created on the travel booking namespace, and this is the booking service. Let me open this and let me keep for last 30 minutes, and I want to refresh for every 5 seconds, guys. Okay, so right now we don't have any data because just now we installed this Prometheus, Grafana, and alert manager, guys. Okay, so let me select here dashboards and let me come down, and here you can see this is the overview dashboard, meaning travel booking overview dashboard. So let me open this and let me keep last 30 minutes and let me keep for 5 seconds. Okay, so let me select here booking service. Let me open this travel booking overview. Okay, so now let me select here last 30 minutes, and I want to refresh for 5 seconds, guys. Okay. So here you can see it is going to show us total request rate, overall error rate, payment success rate, notification queue size, request per service, and response time, and GKE cluster CPU usage, GKE cluster memory usage. It is going to show us everything in live, guys. Okay. So similarly, it is going to show for every microservice. So this is the notification microservice dashboard, and this is the payment service dashboard, and this is the search service dashboard, and this is the user service dashboard, and finally this is the booking service dashboard, guys. Okay. So now let me open this payment service dashboard, and let me keep last 24 hours, last 30 minutes. Okay, and for every 5 seconds. Okay, so here it is going to show us all the payment success rate, total amount processed, and payments per minute, response time, and pod memory usage. Okay, it is going to show us everything. So here it is going to show us the total amount which was collected from travel booking application, guys. Okay, so I will set up HTTPS after 6 hours, so then it is going to show us all the payments and everything, guys. Okay, I will show you that later. Meanwhile, let me open notification service. So similarly, in notification service, you can see notifications sent per minute, and queue size, and email sent per minute, and everything. And similarly, in user service, you can see request rate, error rate, response time, and active connections, and pod CPU usage, and login rate, and response time percentile case. Okay, it is going to show us these things. So now let me come out from this dashboard, and let me open this travel booking overview dashboard. So now let's try to test this travel booking application once again. Okay, so Jenkins is also working fine. We can able to access our main UI using vijayagidithuri.in, and Jenkins at /Jenkins, and Grafana at /Grafana, Prometheus at /Prometheus, and Alert Manager at /Alert Manager, guys. Okay, so now once again let's try to test this application. Before that, I think we have created 3 different users, right? So let me check those 3 users. Let me open this docs and Postgres database guide, and let me come down and see all registers users, guys. Okay, so let me copy this first command. We need to see 3 users, guys. Okay, let me run this command, and here you can see earlier we created 3 users last, I think, around 15 hours ago. So now I'm going to check these 3 users. I'm going to check these login connections, guys. Okay, whether it can able to log in or not. So now, so the first email is shravani@gmail.com. Let me copy this, and here email address I'm going to provide this, and password shravani@123, and sign in. So now here you can see I can able to log in with Shravani user and my trips. So Shravani haven't booked any flight and hotel. So now let's try to book one flight. So I'm going to book from San Francisco to Los Angeles, and I want to book on 19th of this month, and search flights. And here I'm going to provide high to low, and I'm going to book this flight, and first name Shravani. Okay, email address shravani@gmail.com, and phone number 1234567890. Okay, so this is the mobile number I'm going to provide. So this page is handling by the booking service, guys. Okay, so now here if I select confirm and pay, this will be handled by the payment service. So now I'm going to select this. So now here you need to provide all your card details, so you can directly provide some dummy values, guys. Okay, 1234567890, and okay, so I'm going to provide this card name Shravani, and expiry 0930, and CVV 566. And now if I select here pay, this will be handled by the payment services. Okay, so here you can see payment confirmed. So now in my tips page, she can see all his payments. So if she want to cancel this flight, she can directly cancel this case. Okay, so in upcoming she can see this flight, and if she want to cancel this flight, she can directly cancel this case. Okay, so now let's try to log into my user, which is Vijay. So I'm going to select here sign out, and vijay@gmail.com, password vijay@123, and sign in. And I didn't order any single flight and hotel, guys. Okay. Now I'm going to sign out and let me check another user, naresh@gmail.com and naresh@123 and sign in. And using this Naresh user, previously I booked two flights and one hotel, I guess. Okay. So here you can see one flight and one hotel I booked. Okay. So we can see these details. So similarly, like this, you can test this application, guys. Okay. Now let's try to run some Prometheus queries, and after that let's directly jump onto HTTPS setup. So let me open this GitHub once again, and let me directly open this monitoring.md file, and let me come down, and here I have written few of the Prometheus queries. So now let me, if you want to see all the targets are up or not, you can directly open this Prometheus and in enter expressions. So you can directly run up and execute. And here you can see it is going to show you all the targets. So similarly, if you want to show all the travel booking targets, you can directly run this query, remove this up and paste this and execute, guys. Okay, so here you can see it is going to show you something like this. Next, if you want to see HTTP request handled by the user service, so you can directly run this Prometheus query. Let me remove this, and this is the response, guys. Okay, so similarly, if you want to see HTTP request handling by the search service, so you can directly run this, and these are the HTTP request handling by the search service. So similarly, if you want to check for booking service, payment service, and notification service, you can directly run these three queries, guys. Okay. Now, if you want to see successful payments, you can directly run this query. Let me remove this and paste it here and execute. And here you can see it is responding. So now, if you want to see failed payments, you can directly copy this and directly run this query, and here you can see it is right now we don't have a single failed payment, guys. Okay, so now let's come down, and if you want to see total money processed on USD, you can directly copy this query and you can directly run this query and execute. And here you can see total we have 1227 USD. So now if you want to search catchy hits from Redis, you can directly copy this query, directly paste it here and execute, guys. Okay. So here you can see this is the response we are getting. So similarly, if you want to see notification queue size, you can directly run this, and pod restart counts, you can directly run this. So this is the main query. Let me come here and let me paste it here and execute. So here you can see right now we don't have even single restart, guys. Okay, for all the services. Now let me open this. Now if you want to see deployment replicas available, you can directly run this query, remove this and execute. Okay, so you can see this response. So now finally let's come down. If you want to see memory usage per container in MBs, you can directly run this query, guys. Okay, directly remove this and execute. Okay, so this is how it is going to show us everything, guys. Okay, so all the Prometheus queries are working fine, so you can directly run this Prometheus queries, guys. Okay, so now let me open this travel booking application. So right now we were able to access with vijay.3.in, right? So but this is not secure for all the services if you observe. Okay, now let's try to implement HTTPS connection for our domain, guys. Okay, now let's set up HTTPS connection for our domain. So before that, let me give you some clarification on HTTPS. So basically, HTTPS encrypts all traffic between the user's browser and our application. Without this, passwords and payment details will be sent in a plain text. Browser shows not secure warning. So we are using Cert Manager to automatically get free SSL certificates from Let's Encrypt. Okay. So you can follow this documentation. So inside docs, you can directly follow this https setup guide.md file to set up https connection for our travel booking application. So now let me come down. So this is the very first step. So in the very first step, we are going to install Cert Manager via Helm into its own namespace. And here Cert Manager is a Kubernetes add-on that automates the entire certificates lifecycle, like requesting, issuing, and renewing SSL certificates case. Okay. So now let me apply this ML. So initially we are going to add this Jetstack Helm repository. Next it is going to update this. Next it is going to create a namespace called Cert Manager, and we are going to install this Helm chart into this Cert Manager namespace with gateway API supported guys. Okay. So now let me copy this entire command and let me open this terminal and let me clear the screen. Now first let me run this command kubectl get pods -n travel booking. Okay, so all the pods in running state. Let me check for the gateway kubectl get gateway -n travel booking. Okay, now kubectl get ns. So here you can see right now we don't have this namespace with name cert manager, right? So here you can see we don't have namespace with name cert manager. So now let me tell this, and here you can see Helm chart has been added successfully and the repo is also updated successfully and namespace is created. So right now it is installing this cert manager Helm chart case. Okay, so let's wait for some time. And here you can see it was successfully installed. So name is Cert Manager, last deployed on Sunday, May 17th, and namespace it's created on Cert Manager, and status is deployed, and the revision is 1 days. Okay. So now let me run this command kubectl get ns and kubectl get all -n. So this is the namespace case. Okay, Cert Manager it's created last 90 seconds ago. So now here I'm going to provide Cert Manager. Okay. It will display all the pods, deployment services, replica sets for this set manager case. Okay. So here you can see this is the set manager pod and this is the set manager CA injected and this is the set manager webhook. So similarly, this is the set manager service. So this is the set manager CA injected. So this is the set manager webhook case. Okay. So this is the deployment and this is the replica set. So now let me open this documentation. So now let's go on to the second step. So in step 2, we are going to create cluster issuer. So basically this tells set manager where to get certificates from the Let's Encrypt production server. And it also configures how to verify our own domain by creating a temporary HTTP route on our gateway that responds to Let's Encrypt challenge request case. Okay. So now let me copy this. Before this, you need to update this email address case. Okay. So here you can directly provide your dummy email address. That is also not a problem. So now I'm going to copy this and let me clear the screen and let me paste it here guys. Okay, and here you can see it's created successfully. Now let's verify this. So you can directly run this command kubectl get cluster issuer and let me hit enter. So here you can see it's created last 12 seconds ago guys. Okay, so now let's move on to step 3. So this is the step 3. And in step 3, we are going to request actual certificate for our domain. And the cert manager handles everything, like it starts the verification challenge, waits for Let's Encrypt to verify, and stores the issued certificate as a Kubernetes secret. And basically takes around 2 to 5 minutes. And if it fails for the very first time, you can delete and recreate once again, guys. Okay. So now I'm going to create this certificate and let me copy this and let me paste it here. Okay. So certificate has been created. So now if you want to verify this, you can directly run this command kubectl get certificates -n travel booking. So we are creating this certificate in the travel booking namespace case. Okay. Now let me copy this and let me paste it here. Okay. Let me copy this once again. And here you can see this is the certificate, but currently ready is showing false case. Okay. So now let's check for challenges. Let me copy this and let me paste it here. Okay, let me copy this once again. So here you can see state, we need to see this as pending because it is passed, guys. Okay, so now let me check TLS secret is created or not. Let me copy this and let me paste it here. Okay, let me copy once again. So we need to see TLS secret, guys. Okay, okay, so error from server, so still it's not created. So let's wait for some time. So basically it will take around 3 to 5 minutes to create this everything. So meanwhile, let's update this gateway in step 4. So in step 4, we are going to update gateway with HTTPS listener. So once the certificate is ready, we need to add an HTTPS listener on port 443 to the gateway. This listener references the TLS secret which is created by site manager, and the gateway can decrypt HTTPS traffic and forward it to the pods, guys. Okay, so now let's update this gateway with HTTPS. So here you can see initially we created gateway with only HTTP. So let me open this Helm chart and templates and HTTP routes and gateway. Okay, so here you can see listeners, initially we created with only HTTP, right? So now what we are going to do is we are going to update one another listener with HTTPS, guys. Okay, with our TLS secret. So once again let me check for this TLS secret, and here you can see TLS secret is created, guys. Okay, after last 64 seconds ago. Okay, so as I said, you need to wait for at least 3 to 5 minutes to complete this everything. Now let me create this gateway, meaning I'm going to just update this gateway with this HTTPS listener, guys. Okay, and with our TLS secret. Let me copy this and let me paste it here. Okay, let me remove this once again. Copy, paste. Okay, and here you can see it's configured successfully, meaning it's updated successfully. So now let's come down. Now this step 5 is optional. So in this step we are going to create special HTTP route that only attaches the HTTP listener using section name HTTP. Instead of routing to backend, it returns a 301 redirection to HTTPS, case. Okay, so any user visiting at HTTP, automatically they will get redirected to HTTPS, case. Okay, so now I'm going to apply this redirection ML, and let me come down and let me paste it here. Okay, so let me remove this, let me copy this and let me paste it here, and here you can see it's created successfully. Now let me open this. Now let's go to the final step, which is step 6. Now in step 6 we are going to test HTTPS connection. Basically it needs to return status code 200 for all the services. So it checks the certificate from Let's Encrypt and confirm HTTP returns 301 redirection to HTTPS case. Okay, so the final thing is certificate auto renewal. So basically, Let's Encrypt certificates expires in 90 days and Cert Manager auto renews them 30 days before expiry. Okay. So here no manual work needed after initial setup, guys. Okay. So now let's test this HTTPS connection for our travel booking application and for Jenkins and for Grafana, Prometheus and Alert Manager, guys. Okay. So now let's test from this web. So let me copy this HTTPS, or else first let me test this redirection. So let's try to access with HTTP. Let me clear the screen and let me paste it here. So status HTTP 000 it is showing. I think still it's not updated. Now let me check for HTTPS, or else let me copy this and let me paste it here. Okay, it's showing 000. So now let me refresh this page. Okay, I can't able to access even single application. Let me do one thing. kubectl get gateway hyphen n travel booking. Okay, so this is the gateway. So now let me check for the domain. Let's look up vijaygirituri.in. Okay, so here it is showing some different IP guys. Okay, so let me check this IP in load balancing. Let me open this load balancing. Okay, so let me open static IPs also parallelly, IP addresses. So, okay, so travel booking gateway is using this same IP address. So, and in GoDaddy, it is showing some different IP. So, let's try to check this in GoDaddy itself. Let me open this GoDaddy and 34.54.11.57 and 34.54.11.57, and let me check for gateway 34.54.11.71 guys. Okay, 11.71 and 11.71. So everything is okay. So let me run this command once again. Okay, it is showing the same IP address. So I think let's wait for some time. So here you can see after 5 minutes this HTTPS connection started working. For front end it is showing status code 200, and for Jenkins HTTPS status code is showing 200, and for Grafana it is 302, and for alert manager it is 301. Everything is working fine guys. Okay, and here you can see we have same IP for gateway and as well as for domain guys. Okay, so now let's try to access our entire application like our travel booking application, Prometheus, Grafana, Jenkins, alert manager, everything using HTTPS connection guys. Okay, so now https://vijaygirituri.in. So now it needs to redirect to our travel booking application. So here you can see now, right now we are accessing with HTTPS connection guys. Okay, and if I select this, and here you can see connection is secure, and if you want to see the certificate, so this is the certificate. Okay, HTTPS connection is working for this travel booking platform. Similarly, let me access Jenkins, vijaygirituri.in/Jenkins. And here you can see Jenkins also I can able to access with HTTPS. So here you can see HTTPS and the connection is secure. And username I'm going to provide Vijay, password Vijay at the rate 123, and sign in. Okay. And here you can see this is the pipeline, and we can see previous builds case. Okay. So now let me open for Grafana https://vijaygirituri.in/Grafana, and here you can see we can able to access Grafana with HTTPS. So here you can see HTTPS and this connection is secure. So let me try to connect to this Grafana. So here username is admin, and let me get this password from monitoring.md file, and let me come to bottom of this. So here you can see this is the Grafana password. Let me copy this and let me paste it here and log in. And here you can see we can able to successfully access Grafana with HTTPS case. Okay, and if you want to check all the dashboards, you can see all the dashboards are available: notification, payment, and search, and travel booking overview, user service, and here you can see booking service, and this is the alert manager overview dashboard case. Okay, so basically you can see all the dashboards and we can able to access with HTTPS connection. Now let's try to access Prometheus, https ://vijaygirituri.in/Prometheus, and here you can see we can able to access Prometheus with HTTPS, and here the connection is secure guys. Okay, so here you can see connection is secure. So now if you want to run some Prometheus queries, you can directly run these queries guys. Okay, so finally let's try to access alert manager https://vijaygirituri.in/alert manager, and here you can see we can able to access alert manager with HTTPS, and here you can see let me open this and here you can see connection is secure, guys. Okay, so this is how it is going to work. So finally, let me try to log into this travel booking application with my details, vijay@gmail.com. So the password is vijay@123 and sign in. Okay, and here you can say I can able to sign in. So now if I want to check all my trips, so here you can see only I booked a single flight. So now if I want to, let's try to book some hotel, guys. Okay, hotels, and city is London, and check-in time, let's keep as it is, check-in and check-out, and guests are two, and search hotels. So we have these two hotels. So I'm going to book this hotel in London. So this will be handled by the booking service, and previously search is handled by the search service, guys. Okay, and here I'm going to provide these details: 1 2 3 4 5 6 7 8 9 0. And here you can see this page will be handled by the booking service. And now if I select here confirm and pay, this will be handled by the payment service. You need to provide your card number, card holder name, expiry, CVV. So here you can see here it is not showing anything, right? So now if I provide this card number, here you can see it is showing these details. Okay, so this is how it is going to work. So now card holder name I'm going to provide Vijay. So here you can see card holder name is Vijay. Now let me provide expiry 009 and 28 and CVV. So if I select here CVV, here it will not going to show any details, guys. Okay, for card number, card holder name, and for expiry, it is going to show some details like this. But if you are selecting CVV, it will not show the details, guys. Okay, let me select 455 and let me select here pay, and this will be handled by the payment service, guys. Okay, and payment is confirmed, and in my trips page you can see all these, guys. Okay, and if you want to cancel some flights or hotels, you can directly cancel this. So let me cancel this flight and cancel and okay. And here you can see it has went to cancel. Okay. And yes, that's it for this today's project. So I will provide this complete GitHub repository in this video description, guys. Okay. So basically you can follow this GitHub repository and you can directly deploy this application, guys. Okay. So, and yes, that's it for today's video. So after completing your labs and everything, try to delete all the resources, guys. Okay. So initially, if you created this GKE cluster manually from Google Cloud Console, you need to delete the GKE cluster manually from Google Cloud Console, and next you need to run Terraform destroy command. Or else if you are created all these resources using Terraform, you can directly run Terraform destroy command, guys. Okay. So that is going to destroy everything. So first I'm going to destroy this GKE cluster. Let me select here Kubernetes engine and clusters. And here you can see this is my GKE cluster. So we need to select this and we need to select here delete. And here you need to provide this name, which is travel booking cluster. And let me paste it here and delete. So now it is going to delete this cluster, guys. Okay. Now from now we cannot able to access this travel booking platform, Prometheus, Grafana, Alert Manager, Jenkins, and everything else. Okay. So let me refresh this. Right now we can able to access, but after 5 to 10 minutes we cannot able to access all these five services, guys. Okay, because we are directly deleting this GKE cluster from Google Cloud. So once after deleting this GKE cluster, you can directly delete all your Terraform resources. Let me do ls and GCP hyphen Terraform state list. So a part of GKE, we created artifact registries and VPC, static IP, and subnets and firewalls, right? So it is going to delete all these guys. Okay. So before that, we need to wait till this GKE cluster is deleted, guys. Okay. So if you want to delete this, you can directly run this command. Let me open this terraform.md and let me come down. And let me come down. Okay, so you can directly run this command. Let me paste it here. So terraform destroy hyphen auto hyphen approve and targets. We are going to remove this module VPC, module firewall, module artifact registry, and module static IP, guys. Okay, so if you are created a GKE cluster with Terraform, you can directly run Terraform destroy hyphen hyphen auto hyphen approve guys. Okay, so that is going to destroy everything else. Okay, so and yes, that's it for today's video. And if you like my video, please do like, share, and subscribe to my YouTube channel. And see you in the next video. And bye.